Alrighty, how are we doing? I'm back, and we're going to do more calibration, but things are getting out of hand. Things are getting a little out of hand with this design. There's a bit of a problem with the different ways that I have to sense. Wait, where'd my regular Streamlabs go? Or my Twitch page? Uh-oh. Gotta open that one up. Bother. All the way here, and we're going to not use this view. Apple rewards are enabled. Can I disable them? There's my dashboard. That's what I'm looking for. I'm live? Oh my god. Manage stream. Where's my dash? I said to go to my dashboard and it didn't go to my dashboard. Jesus Christ. What are these Apple Plus rewards? I don't have Apple Plus. They're not giving me a free Apple Plus subscription as a result of this. Why is that automatically enabled on my... It's all this money grubbing. This platform used to not suffer from all that. They used to let the streamer be the greedy one. Sign up for this promotional pop-up. It's like, no, we've been through this era of internet before where pop-ups took over and it's all coming back. Ooh, not a lot of people here. I haven't done a Saturday stream for quite a while, and I kind of owe you guys after skipping out on Friday. I had some stuff that I had to deal with on Friday, so yeah. Now we're here and we're ready to continue work on this module testing module. It is getting out of control, and I think what I'm going to do is try to take shortcuts because all the hardware is almost vetted out. I need to make sure I can get a couple I2C things running at once, and then the screen. The screen's going to be a struggle. And then with the I2C things, we get buttons and the knob and stuff. And so that'll pretty much be the hardware portion of this. So once all the hardware is figured out, it's down to making a UI for the screen. And then I can leave it to the user of the program to set up whatever test they want to. I should probably have the ability to save a test. You know, save a configuration. Hold on, I'm hiccuping. I start talking and my diaphragm is like, hold on a sec, I need to adjust something. I need to, hold on, one sec. Diaphragm's like messing with my speech. How's my bitrate doing? It says it's red, but I've got 5,927. I guess that's okay. Pre-roll, what's that all about? Session time. Session time is just how long I have this web page open. Okay, yeah, good stuff. Bonk, go over to there. So I got a MIDI keyboard. I don't even have a MIDI cable yet. Hey, what's up, Madam? You did show up on the chat. Oh, there we go, perfect. How you doing? Yeah, it's gonna be a nice quiet stream today. We got work to do, so I wanna get this hardware all set up so that we can jump into, I mean, what I can do is start to build the hardware too. We can have a couple building streams as well. Once we vet out the fact, because we have to make sure that this stuff will work all at once. So I don't want to run into any problems where something like can't resolve something fast enough. Now, what is the positive and negative voltage supply modules that I have? Is it specific for negative 10 volts? What are those? Let's open up a mutable instrument schematic. That'll have it in there. Oh my god, this computer, like OBS had a memory problem. This computer is probably not in the best shape right now. I probably need to restart it and update a few programs. What I'd love to do at some point soon is blow up OBS and start it all over again. You know, get the new version of OBS, start a new couple, like a new chapter of or whatever, a new grouping of scenes, and then just put it all back together. Maybe spruce it up a little bit, right? Shouldn't this be spruced up a little bit? I don't want to have like circuit board elements in the backgrounds of these things, but it could use something. Or it should just be organically in there. Although if it is organically in there, then you guys see that I have this chat window open right next door. You guys don't need to look at that. So we're done looking at this stuff. Turns out most of these ADCs either don't operate where we want them to, or they have some kind of a low-pass filter built into them. And that low-pass filter keeps me from measuring DC on the side. So we need a separate element that's going to measure DC on the side. which means that it could fall out of calibration, which is a little bit weird and scary. I don't want that thing to fall out of calibration. I wanted my own elements to test themselves, but we're going to have to bring in a third party as a comparative tester. So we'll have it be able to be exposed to the voltage references, and then it'll say, okay, so this is that voltage reference, and then we'll have other elements read that same voltage reference, and then we can mash all of our numbers together and have them all come out to be the same things. We'll have to figure out how we're going to set up that whole test. It'll have to be like a startup algorithm that we do. Oh yeah, I need mutable instruments schematics. A lot of people have dumps for this stuff. They're not comprehensive, but they have enough. Marbleps would be good. There are marbleps in here. Huh, weird. I guess we could just grab, like, clouds. I think clouds has some op-ampy stuff in it. Yeah, there we go. So where's our control signals? Here we go. AREF, -10. What is that AREF? Where is it? It's in the power supply. We go all the way down to the power supply. There we go. And we have LM4040B10. B10, voltage reference. This is start soon. This is basically me doing my homework right before class. No results. What the hell? Shunt voltage regulator. I'm going to see if I can make this thing make 10 volts, not just -10. So I'm going to look at the data sheet, and it's a family of products with fixed voltages. Basically, all it is, it's just a shunt regulator, huh? We'll be using 2 of these, I guess. I'll bring in another one and make it a positive one. I just want a confirmation on the schematic. I don't think there's any particular reason why this can't be a positive shunt. That's the block diagram. Might be trouble. The hell is that thing? Data acquisition circuit with an LM4040. Okay. You're just putting it in VREF. You could, this whole diagram, this meeting could have been an email. That whole diagram could have just been this. So how is mutables using? So from VEE to ground, AREF -10 running in the opposite direction. VEE would be the negative supply voltage. VCC would be +12. So we're going to be going from VCC. I don't have that capacitor in there either. Ours gets very, very hot, too. It's dumping that 2 volts into heat with alacrity. I suppose we're just going to be putting an RS on there. VS minus VZ, IL as in load current. I don't know what the load current's going to be. It's just a reference. And it's barely ever going to be used. It'll barely ever be used in the circuit. It'll be flipped to at startup in order to calibrate, and then that's it. Modern data converters use calibration techniques to compensate for any error induced by VREF's inaccuracy. Hey, that's me. It's best to use the highest accuracy available. This is due to errors calibration method that may allow some nonlinearities and initial accuracy. Good examples, the LM404041 is designed to be cost-effective voltage reference requiring 12-bit data acquisition systems. 12-bit systems operating for 5-volt supplies, LM404041 is 4.096 volts. 0.01% plus minus. Only just 4 least significant bits, 4 millivolts of possible error in a system that consists of 4096 LSB. Damn. I think we're going to be punching above our grade here. We're going to be using like scientific level accuracies on a hobby device, which is what I like. That's what I like. The output does not require an output capacitor across the cathode and anode for stability. However, if an output bypass capacitor is desired, the LM4040 is designed to be stable with all capacitive loads. Okay. SOT23, startup characteristics, don't care. Yeah, so we're just basically hooking this thing as a shunt. Did we listen? We listened to this mix, didn't we? This is the mix number 2. I thought it was mix number 1. Oh, numbers are going to be abysmal today, aren't they? We're not going to have great numbers. I shouldn't worry about this kind of thing. It's non-becoming of a streamer to complain about numbers, but you know, I've been streaming a lot lately, so I need to get back into my schedule and really get pumping. We need to pump on some of these projects here and get them done. I've been working on the CNC, which is all of these parts here. No, that's the wrong one. Where's the... Wait, where did my camera angle go? Oh, I didn't scroll up on the scenes. That's another thing, is I have so many scenes here that I don't use anymore. Did streams start? Look, why does somebody always have to ask this? And I have to be the one that explains it. Other streamers don't have to deal with this. They don't have to deal with this. Why do I have to deal with it? Why is Bother the one that has to demystify the wide world of streaming and how it works as a whole? I am under no obligation to actually be talking to you guys right now. I could put up stream starts and I could just sit behind the computer making no noise at all whatsoever. But what I do is I start up stream and I hang out with you guys for a little bit. And nobody seems to understand that. Nobody gets it. Nobody really gets it, guys. Try to show as much of this equipment as possible. The synthesizer's sitting under the desk there, but... So I've been amassing parts for a CNC build, and I'm debating whether or not I want to do belts or rods. Now, this is going to be belts no matter what. This is the X-axis. I got this for $40 on Amazon, and I have it running with my O-Drive NEMA 23 adapter. Not O-Drive, it's actually going to be Granite Devices, but it's a NEMA 23 adapter for one of these big robotic outrunner motors, and those are going to power this whole thing. I didn't want to have 4 axes, but I guess I'm going to end up having 4 separate axes. One of them will just be, it'll be like right and left gantry, and then one to move the thing back and forth, and then this one moves it up and down. So this one's going to be a belt. There's no getting around that. But I'm wondering if I want to do screws on these and then use these big linear bearings that I have. I think I might want to do that, because then it will be expandable. You could make a fishing reel with that. Why would I do that? Why would I do that? Yeah, so I'm debating on what hardware I want, because if I do belts, I might have enough stuff for the belts. But if I'm doing gear reductions on it, I should be using screws, because screws have way less backlash than belts. Belts are kind of not friends for a CNC machine, especially if you're going up to like aluminum and anything harder than that on your CNC. The belts are gonna stretch and do bad things. So I might opt to do rods on the whole thing, which means I have a bunch of hardware to buy. I have to buy a bunch of hardware, and each of the gear reductions that I would want to run on the thing, because like those motors like to go fast. They're not torquey. Use a bicycle chain. That has a ton of that. What are you talking about? Hey, Brink, what's going up on? There's a little train wreck in my brain just then. What's going on? I'm talking about the CNC machine right now. When you have belts on a CNC, like those timing belts are what they're called, they are pretty good. They do a really good job. I mean, I've got them on my 3D printer, right? And they work great on the 3D printer. What I'm trying to do is make a CNC running to Micro Center. Need anything? Are you going to my Micro Center? My Micro Center is in St. David's. SSD 1306 OLED work. Nice. Good job, Mark Slug. Those things are great. I've got 2 circle displays that I'm going to need to work with when I get to it. When I build Julian his little oscilloscope. The Brooklyn one. Oh, that's a good one. I know that's a very good one. Have fun. That's like a whole day. That's a whole day. You're not going to be able to get out of there. Like, there's water cooling stuff. There's all kinds of great things there. And there's a whole Arduino section. No, but okay, so for the CNC, I'm thinking like, I could build it out of belts. I've got the belts, I've got the nylon rollers. I've kind of just made the decision that instead what I want to do is make it super duper accurate and have gear reductions on the motors, because I'm using servo motors, right? these servo motors like to go fast. That thing on the right is an Outrunner servo motor that's been adapted to a NEMA 23 mount. And what I can then do is throw a gear reduction on it so that the servo motors have to move super fast, like a 10-to-1 ratio, in order to move things around properly. Now for the Z-axis, this thing with the belts that I've got going on there, that's already a pretty good reduction. It's not going to be as big of a reduction, but the belt is okay there because you basically park your Z-axis. But if I do gear reductions, then these servo motors will be utilized a little bit more at, at their comfort zone. And then it'll still be super fast, because remember, it's not a stepper motor, it is a 3-phase servo motor. So that thing will be able to scream and just move everything around. If I do screws, though, that means that my two sides, the two sides of the gantry, will have to be independent. So I have the Granite Devices 4-channel motor driver, and I have 4 motor controllers. So it's going to have to be 2 separate motors on the 2 sides, which I didn't really like the prospect of that. I thought I might be able to use one to control the spindle, but it turns out like the two sides aren't going to be connected, which is unfortunate. But I guess that's just what I got to live with. And then the spindle, I'll have to do like a PID control for the DeWalt router, and that'll make a pretty tasty CNC. I'm actually kind of excited about that. But if I do everything with linear rails, I'm gonna have to buy a couple more of those carts, and I can cut up the 1500mm linear rail that was meant to be on this thing. It turned out to be too big. I mean, if you're just moving a laser around, you can use the dinky little ones. I wouldn't like it if I only had AliExpress to order from. I have options here. I'm in North America. I'm right in the middle of the Northeast, so it's super easy for me to source things. I can order from Amazon, and I can get it same day sometimes. I can order from Micro Center by walking there. I can't really walk there. It's a short drive, but it's not that long of a drive. It's actually just up the street, really. Or I can order from eBay, and most North America things ship here, and then AliExpress with their USA warehouses that they have now. So my options are insane here. It's like, it doesn't make much sense for me to move, aside from the fact that everywhere else has healthcare. Wish I had healthcare. I'm on a public plan right now, which means I can't earn a certain amount of money. I have to remain poor. But I'm rich in modules. Not often anyone can see a servo motor control aside from in aviation. Generally, to understand a system like that takes more theory and understanding than most want to bother with. The Granite Devices controller, you do have to do a little bit of characterization of your motors, which I've done on these. We did that in previous. That's what that setup is up at the top of the frame. You can see that there's a right angle mount with a bunch of holes in it, and then an aluminum block. And what that is my motor characterization stand. Geez, customerization seminar. That's my characterization stand, and what that does is that locks down the motor so that I can lock the spindle or just observe how it's moving in order to get things into tune. Now, I've forgotten everything about that, so we may have to go back to that when we get more into the CNC project, but that one's sort of a slow burn. So over the next month or two, I guess I'm going to be getting screw hardware, as well as a couple more carts for the big linear rail that I've got sitting over there. I was going to go with nylon rollers and belts, but I did a little bit of reading. I found a hobby CNC subreddit and did a little bit of reading, and I'm like, okay, well, people have trepidation about using belts. We're going to use big, thick, meaty belts that are typically used in CNCs like this, but if I'm going to do the special thing and use servos, which are super duper accurate, under a gear reduction, which will make it even more accurate, it'll be really, really nice, and it'll function within like the miniature parameters that I would like to try to get out of the thing. I really like nylon. I don't like the nylon rollers because I tension them all wrong, and then they all go bad. They all turn into soup on me. I don't know why. But the linear bearings really helped my 3D printer, so I figure I can use them here too. And I got to cut those with a grinding wheel. Nylon bearings. The nylon rollers are what we typically have in the printers and stuff. The tooth belt is what the tooth belt is what people have trepidation about. These are the nylon rollers, and they use that 2020 rail as a guide. They're really good for like 3D printers, laser etching setups, stuff like that. Like these are fine, but when you really get down to the brass tacks, these are less strong. Bicycle chain is out. Bicycle chain would not work the way... I think bicycle chain has significant backlash, depending. Sylar Atomic. Sylar Atomic. That's a strong name. That is a strong name. Thank you for the raid. How you guys doing? Oh wait, the raid, the Streamlabs indicator doesn't get larger with the... Hold on, I need to do that. There we go. Oh, it's actually down here. Okay. There we go. That's more. Yeah, there we go. Hey, thank you for the raid. Kindly put your memes in the bag. We don't have many memes here. I have one meme, and that was Tub Bro. There's a controller that I took apart, and actually I used parts from that controller to make Tom Thinks' voice changing button. But if you guys know Tom Thinks, I don't know if you guys know who he is. He did a lot of the Twitch ads that were recently done. But the meme was when we were taking apart that, like, you know, third-party controller. It's like the controller you give your little brother. What do you call it? The turbo button was misspelled, so it was a Tub Bro button. You're like, Tub Bro, what do you think? Just do Tub Bro. How you guys doing? Thank you for the raid. What goes on over there at the Atomic Sylars area? The Sylar is such a villain name. You guys are an oh bother shop now. You're on my turf. We got a bunch of stuff going on, actually. Bunch of stuff going on. The main thing that we're working on today is going to be all of this crap. All this bullshit that I've put onto this solderless breadboard is actually making a blender for tower defense. Hell yeah. We're working on modular synthesizer stuff right now, which I've gotten way too into and distracted to get other projects that have higher profile done. Dave has an M303. My buddy Dave has an M303, and it is broken. And in trying to fix it, I've pulled out all the stops, and I've relied on my 10 years of reverse engineering experience in order to try to figure out how the hell this thing works so that I can know how it broke. But the problem is I've run into troubles. And one of the main troubles I've run into is that I don't have the right stuff to test a modular synthesizer module. So we're taking cues on stuff that other people have built, and we're making a module testing module. What that means is that I have multiple channels of audio or control signal output going into amplifiers that bring it up to modular synthesizer voltages. Then on those same channels, audio comes back in and gets selected by an actual like audio sensing circuit. So we have high voltage audio coming in, getting tamped down to what this thing can handle, and then piped back into our microcontroller. And then, just for fun, I output that data on a separate channel so we can observe it again. What we're working on today is I need to make voltage reference sources so that we are able to flip to, using this mux over here, flip to that voltage reference, calibrate the microcontroller's numbers depending on what we see on the input, output a voltage level, see what we see on the input, and calibrate that. We're doing it's just this whole circular thing where this thing calibrates its stuff. Other stuff that we've worked on this channel and I need to get done, burn the subs. That giant block of wood that's on my wall, that giant block of wood is designed to burn the name, you lost me at bread, yeah, well, me too. That thing on my wall is actually a giant XY table. And what it is designed to do is burn the names of subscribers onto the wood. So if you sub to the channel, pew pew pew, laser, burns your name onto the board. Now, obviously that doesn't work yet. I have two other boards that are filled with something like 7,000 names, right? It was a staple here for a while. It's been a couple years. It's been since the beginning of the pandemic that the board filled up and I stopped. It was basically around the same time as the pandemic, which is a crazy long amount of time. But I've been interstitially working on this project, and it hasn't sort of gotten to the point where we've done anything with it. So this thing is almost done in terms of hardware. At some point, we'll stop everything we're doing now, and I'll bring the cameras over to the table over there, and we can just sit down and finish that part of the hardware. Then there's a little bit of stuff to do like internally on it. That would make a sick coffee table. I have the two old boards. They're actually mounted behind my gaming computer. Here. Maybe I can show it without totally showing off that I'm a slob. But you can see right there, there's 2 boards sitting behind that computer that are just filled with names. And that's where the old boards have gone. For now. When will the subscriber burner be working? I don't know. I actually don't know. I'm getting to the point where we can start really cinching up that hardware and like getting it done. We've done a lot of custom printing for the control block on it. Did you pick a cool font? Yeah, the font is called Avenir. Avenir. It's a very readable font. It's one my design buddy loves using. So, this is the turn signal from a BMW. Anyway, yeah, the other project that I'm working on, hopefully soon, bonk, is a bunch of motion control stuff. Can always trust the design buddy. Yeah, he knows what he's talking about. He knows where to find and how to pick fonts. I have a little bit of, you know, design experience behind me. All of this stuff right here is for my POS CNC. My CNC machine, something that I would like to have, is going to be an extraordinarily capable CNC. I'm going to have gear reductions on all of the axes. I'm going to use screws to turn everything and move stuff around, and there will be a limited number of belts, 1 belt, so that these motors are able to scream at a high speed, because they're good at that. And then I will put together a simple axis to move that DeWalt router around. Hopefully I'll be able to speed control the thing. And that should make a very accurate CNC. I'll be able to move at very tiny increments at very high speeds. Yeah, it'll be high speeds for the motors, not for the axes. But I'll use the big linear rail that I accidentally ordered for Burn the Subs. That's what those long rails are at the bottom. And then we're not going to use nylon rollers, even though I've got a bunch of the hardware sitting right there, which is really annoying. But I hope one day we can just sit down and build the thing. I've got to order a bunch more parts. That is one of the longest partner names. Jesus Christ. If you're on Twitch, you can hear music, but on YouTube and or VOD, you cannot. Playing, I keep forgetting you're not in love anymore. This is Yacht Rock from a music collective that I like called 8 Ball. Not 8 Ball, Space Cowboys. The DJ is 8 Ball, the one that's actually playing the music. But it's Yacht Rock, which is the soft, dickless, soft rock hits of the late 80s. What's up, Anima Rain? Twitch chat wins again. Well, thank you for the raid. We've got kind of a unique and interesting stream here. Unfortunately, we're not doing anything cool. We're going to be working on getting that voltage feedback to work. But we can try to take it easy. We can take it easy. We can take it slow and actually get this stuff done. Although one can choose from music and unmusic stream. Listen, that may seem like a feature. It's not a feature. That was forced upon me by Twitch and the RIAA. They basically, every single audio frequency in existence has been copyrighted. And so the RIAA decided to lean on Twitch to say, hey, a lot of these streamers are playing unpaid for music. You have to actually pay to play these songs. Sometimes a radio station has to pay to play the song. Sometimes they're just given the song to make it popular, but they have to pay to play. And so the music industry, being, you know, sucked dry by all the downloading on the internet, decided to lean on Twitch, and Twitch went, ooh, we're going to be in a big lawsuit. They're going to definitely collectively just fucking destroy us. So what they decided to do is, if audio frequencies are on your stream, you get blown up. They take you out back and they blow you up. They strap C4 to your chest and they go, ha, pff, and then you die. So instead, we have to have a separate audio track, and that separate audio track is not let out to anything else. So the VOD doesn't have the audio track, and YouTube doesn't have the audio track, because YouTube will find me. They'll find me and they'll drill a hole in my brain. So no copyright live stream so I can have music. That's another thing to do, is you can either pay for or very carefully vet out a no copyright system, but Twitch won't let us use copyright music, but people can watch Netflix. I don't know how other people get away with it. I got a visual copyright on YouTube because I had a view that looked like this. We were like this, looking at my monitor and the rack with all my equipment in it, all the streaming equipment in it. We were looking like this, and I had the Prodigy. Yeah, did I say Prodigy? Yes, I said that right. Why did I think I said that wrong? Anyway, we had a Prodigy music video here, the one that had that stop motion. It's a really cool video. While I was walking the dog. And so I had Twitch TV Bother, I had all my cool stuff over there, and we had the music video here in this parallax nightmare of a transformation window that's all washed out, right? And I still got a visual copyright off of that. Absolutely ridiculous. Hey, Madam, welcome to Twitch. Free lobotomy. Yeah, they treated me like Pie the movie. Yeah, can't use music, can't show anything. It's crazy. Twitch might be a little bit more lax about it, but the problem with using like a no copyright music service is if you play a song that's like hot beans, it might get copyrighted later. They might move it over to being something that they don't want people to share for free. So I feel like Free Lobotomy was a name on the old BTS board. That's true. Along with Coming in Santa's Beard. That was a name. Now, the fact that I said the naughty word might mean that this whole thing gets fucking destroyed on YouTube. I haven't started working yet. Does it look like I'm working on a circuit right now? You may be fooled because I'm actually doing my homework ahead of stream. I'm reading up about these voltage sources, these voltage reference things that I use, these shunts that I bought for a different project, about whether or not I can use it as a positive 10-volt source, and I think I can. I think I can. I just need to flip the circuit on its head. Because the circuit that I'm basing it off of is for a negative 10 reference voltage. That's where we can start the stream, actually. Even though I enjoy sitting here and chewing the fat with you guys and listening to music. We have very few viewers right now because my viewers are typically people who are in like an office setting, like an engineering setting. It's really weird that I've cultivated that kind of a crowd, but I have that kind of a crowd, so people will pull me up at work and it'll look like they're watching something related to work stuff. Even though I'm sitting here like farting into a microphone going, I don't know what resistor to use here. It seems enough like work that they can actually get away with having it open in the office. So on weekends, I get far fewer people watching. If we start up the game streams again, maybe I can do that. I mean, we still need to play more Jedi Knight too. I need to bring out all those early 2000s, like completely butt-looking games that are actually very fun. Okay, I watch Boomcat at work. I don't know, it seems like you're hooked up to a different crowd than I know. Boomcat I do not know of. I know I saw a tomato emote earlier, so that was a familiar territory for me. I think I had Benji open in the other window. What are we doing? Let's get the start soon out of here, and let me get the music out of here. Oh, I'm gonna get a copyright strike if I get too accurate in singing along. That has happened. Police Cat, is that like the GTA RP people? Is that what that is? I don't know. I don't know. Welcome to A Bother. Hi, those of you who are familiar with me, shut up. Those who are new, we work on electronics projects here. We get a little bit cerebral, we get a little bit too into the projects, we get a little bit too deep into things, and that is sort of where we are right now. I am in the midst of shaving yak. We are at the lowest point I think we're ever going to be. Oh, Unreal Engine VTuber. You guys should, like, if you get a chance, check out what Rabaz is doing during Eastern Standard Time, like night. He's actually working on his first game. He's started to pull out Unity, and I think I saw Blender for a minute, but I use what do I use? I use Fusion 360 for my stuff because I'm doing engineering stuff, and what we're working on is we're actually working on building a modular synthesizer testing module. So I am putting together electronics that will be able to hook up to your typical modular synthesizer signals. And what that includes are plus minus 10 volt control signals. Some things can get above and below that. I think we're going to limit ourselves to 10 volts. So plus minus 10 volt control signals, plus minus, I believe, 2 volt audio signals, 8 volt gate signals, BPM signals, etc., etc., etc. Everything lives within the dome of plus minus 10 volts. So we can make a repeated circuit that will be able to sense voltages on all 6 of the IOs that we have available to us. I want every input to do everything because I want to leave it up to the user to get annoyed about having to assign things to certain values. That way we have universal in-outs on the whole front panel, and then on the screen I can actually denote what things are. These are all 3D models of the parts that we're going to use. Because I have a very fancy vacuum fluorescent display, it's like a $120 display. I got it on eBay for $60 for 2 of them. And I found out why. It's because they're very early models of this particular screen and they only work in a certain way. So it's very annoying to design for them. But this is the VFD display that I would like to be using, and that'll give this thing this kind of cool look to it. It'll have a really cool old VCR style look. So, I have gathered all the hardware. It's a lot of hardware. I've discovered that using a Teensy 4.0 super duper duper simplifies our audio design. Oops, wait, this isn't what I'm trying to go for. That's the reverse engineering of days module. This is just the plan for the front panel. We have an encoder to help us select channels. I have 6 buttons that I'll be able to use in order to induce signals and or anything else that I feel like. We're basing it sort of loosely off of a mutable instruments design for a module tester module, and then we're using the Teensy 4.0 audio design tool in order to hook things up. It's kind of amazing. The Speak and Spell, yeah, Speak and Spell had a character VFD display, but ours is a special super duper. I had it open a minute ago, didn't I? Yeah. This would be. Come on, buddy. Where's the picture? Oh, no, I don't have it. Noritake. Oh, not the design tool. So these look like this. They're pretty cool. The question is whether or not on a character and graphic VFD, if I can actually get usable data on there fast enough. I don't know what the speed is like on these things. And it's more of the communication speed more than anything else in order to display all the stuff. But these are very cool looking modules. So, you know, we'll have a very nice looking display on this thing. I haven't cracked the serial code for this thing yet. We'll get there eventually, but I haven't cracked this because it's a little bit more difficult. See, it'll look kind of like, you know, similar to something like this, which is very neat looking. It's a very neat look. This one seems to go all the way up to the edges. I don't think we're going to have quite all the way up to the edge capability because this is an older display. If I went out and bought like a $200 display, it would look really good. But I think we're going to be well within the bounds of the borders of this thing, which probably means I could back it up a little bit and have that bevel go out into the thing a bit. But hey, Lawn Doug, how you doing? Welcome to Saturday. So the thing that I'm trying to do is calibration. We've got right now, we have sort of this accursed loop that we've set up. What I'm able to do with the Teensy 4.0, and again, I'm able to do it so stupid simply because of the audio design stuff. Like if you're looking to do audio stuff like a guitar pedal in microcontroller stuff, and you want to have audio in and audio out running, find somebody else's project, but then look at the Teensy 4.0, because these $11 for 3 of these I2S, it's like I2C is integrated circuit, IIC communication. I2C is used for a lot of different types of things. Like I have something that has extra ports on it that uses I2C. I have something that has analog inputs on an I2C that are just like, you know, regular microcontroller inputs. There are like temperature sensors. There's all kind of stuff that run on that bus, that I2C bus. It's like a universal bus that engineers can use to make smart chips communicate with microcontrollers. I2S came about because people wanted lossless digital audio formats to run around on a circuit board in a similar manner. So I2S is being used here. Now we could use I2C with these tools, but I2S just has that sort of like high format, you know, detail and stuff like that we want. I just dragged and dropped something on OBS and I don't know what. Let's put that back. So what we're able to do is, much like Node-RED, we are able to drag around elements and wire them together. And when we do that, we can then export the code and it'll run in Arduino. Now, Arduino's particular flavor of Teensy support, right? But I don't play the guitar. Well, too bad, too bad. So what I have here are the different audio synth stuff. These are the modules that we're wiring together, and then they show what they're wired to. It's just a little patch cord system that wires things together. Pretty cool. From there, you can start whatever waveforms you want, given the amount of audio memory. So what I was able to do in this system is I was able to wire up the Teensy 4.0. Let's get a little closer so you guys can see what I'm talking about. This is the kind of stuff we do here, and it has been a slow buildup of functionality and testing to get here. You don't get here in one day, right? You don't put this entire device down on a piece of paper. You kind of do. You have like a loose plan for what you're going to do, but then you take it piecemeal. Piecemeal, as in, at first, I took the microcontroller and I plopped it down onto this board and I plugged it in. And the first thing I did with a microcontroller was make the LED blink. Actually, a lot of them, the LED blinks out of the box, but you make it blink a little differently, just to make sure that your code can function at all on the platform, right? You don't assume that everything is going to work complicatedly right off the bat. So the first step, Teensy 4.0 down on the board, make it do anything, make it blink an LED. So that was done. That was a fairly simple step. We made this thing blink an LED. Next, I hooked up a singular I2S device. So one of these, which does 2 channels of output. I put it on the solderless breadboard, hooked it up to I2S, hooked it up to power just through USB, and got this thing to output a waveform. So there were a couple little foibles to figure out what to do. You had to actually give it a little bit of audio memory in order to function. And those are the kinds of wrinkles that you have to sort of iron out. Blinky is the hello world of the microcontroller. Yeah, you don't necessarily have text coming out of a microcontroller unless you have a screen or you have a serial print that'll communicate it via USB. So what you do is you either use the LED that's already on the board in order to blink it, or you add an external LED that just uses the power that the microcontroller has. And that's a super simple thing to do. It is trivially easy if your path from computer to microcontroller has already been vetted out. But if it hasn't, or if it's a new microcontroller platform, or it's new software programming it, it helps to have a super duper simple program so that you can make sure that you're able to, because a lot of stuff has to go right for that very boring program to actually function. So I did that, and then I added 1 channel I2S, and then I took that out to a different setup than this for boosting it up to 10 volts, plus minus 10 volts, and everything seemed to function all right. So then I added 2 more channels. Remember, it was $11 for all 3 of these. Pretty crazy. And these things run at plus minus 6 volts, which was a curveball that I didn't expect. Sorry, plus minus 3 volts. Where is it making the minus 3 volts from? I don't know. This thing is only connected to 3.3 volts. Then, while working with it like this, we found out that some of the channels were blanked out. Why were some of the channels blanked out? Well, this thing was getting pretty toasty, so I brought in an external 3-volt regulator, an LM1117, plugged that in, hooked up the external regulator. Now all these things have plenty of power, although this thing gets very hot in operation. Like I said, baby steps, baby steps, baby steps. Then I put together all of these, and I gave them tuning potentiometers. These are op amps that are being set up in such a way, and I can explain this to you guys. I'm trying to be kind of basic about all this stuff, but when you do a comparator, like an op amp, in one of the traditional op amp circuits, restart to install the latest Windows update. Here, basic. You can do a lot of cool stuff with op amps. Op amps are basically, you have 2 inputs, and the inputs are compared to each other in order to produce an output. So you can have a differential signal going into your op amp, and you can have common mode noise get rejected on the 2 lines. That's sort of a little bit of what op amps are all about. There's a bit of a feedback element into op amps in that you have this sort of high gain thing that's comparing these signals. You need to have some type of a feedback in order to bring it back down to where it started. And because it's a ratio between 2 resistors, you then have the ability to go positive and negative. You can go into fractions and it'll lower the amplitude of your signal, or you can have it go into positive numbers and it will multiply your signal. So it's basically the negative of the voltage input times R2 over R1, and R2 is your feedback resistor. The resistor on top is the feedback. So you basically do a divide sign right in the middle of that. That's an inverting op amp. That's the most stable one you want to use for just about everything. The only thing you have to deal with is that it's inverting your signal. If you want a non-inverting input, you can do VE times 1 plus R1 over R2. The nature of the circuit means that the math is slightly different, and it means it's not as versatile as your inverting amplifier. So what you could do is put a signal into an amplifying inverting amplifier amplification, and you can amplify the amplitude of the amplification of the amplitude, and then you can put it into a unity gain inverting amplifier, and that'll flip it back to the positive number line. But you gotta keep special attention to your positives and your negatives. In modular synthesizers, everything works on that number line. Your input power is plus minus 12 volts. The only DC element, there are no DC elements. Your trigger signals might be DC. They would be a positive DC trigger signal. Other than that, everything else is in the AC realm. And so you have to be careful, because some op amps go from ground to power and they don't have the reference for the negatives. And if you put that into like an inverting circuit, it's going to be where the microcontroller, or where the op amp can't produce power. And if we're putting a signal into a microcontroller, microcontrollers typically nowadays can't handle 6, 8, 10 volts. They'll blow up. So what you have to do is you have to scale and offset your signal. So that's where we get to the mutable instruments circuits. Mutable instruments, Amelia Gillette, I believe transitioned to Amelia Gillette. I don't know how exactly to say her name, but I'm doing the best I can. They decided to get out of the modular synthesizer game, and they decided to no longer produce synthesizer modules. But what they've done, their previous work is utter legend. It's some amazing modules. And a lot of these modules use some very powerful microcontrollers. The STM32, which I barely know how to operate. I barely know how to program for this thing. You have to like set up a whole virtual environment in order to do it sanely. But the cool part is that STM32, in all of its power, it can only handle 3 volts. So what we have in the Amelia Gillette circuits are very carefully scaled op amp circuits. We've scaled and offset op amp circuits. So this is an inverting amplifier. So in order to invert it onto the positive number line, because the MCP 6004, the input voltage for that thing is 3.3 volts. So it's between ground and 3v3. Sorry, let me catch up with chat. What are you guys saying? 3D printing, Turning Cog. I'm 3D printing it for now. If I can get that CNC working, what kind of magic is this? I'll explain to you in a minute. It's math magic. This is really cool. I'll explain this in just a second. If I can get the CNC running, which is currently in shambles, if I can get this running, then I can strap pieces of carbon fiber to it, and I can cut all of my front panels out of carbon fiber, which I really want to do. I really want to do that. And then we've got, way in the background, I've got a printer in the other room, a really nice ink tank. Not really nice. I have an ink tank printer in the other room, and if we can fool that into using a linear bed, then I can print using a printer, you know, a normal DPI printer. I can print ultraviolet ink onto the carbon fiber panels, and then when that cures, that means I have an epoxy of a complicated mask on top of carbon fiber. So I can do comprehensive labeling on the module, and it'll have a carbon fiber background. Chef's kiss. I think that would look awesome. Yeah, so that's stuff that I'm working on in the background. But for right now, my plan is to, I print these modules. I print the front panels in gray PETG. Air filtered before carbon fiber cutting. Yeah, I mean, I'll be doing the cutting in the other room, basically. But yeah, so I 3D print the front panels, and sometimes they have labels, usually not, because the labels make the top surface very rough. And then those I just use as a kind of a thick panel substrate. Teensy and PCM 5202 on its way. Time to plan out my electric sax design. Oh, you're making a Tomatone 2.0? That's pretty cool. Yeah, the Teensy audio tools are very cool, and they're very easy to work with. We'll make sure Bother doesn't injure himself. Yeah, I've got plenty of air filtering devices that I can put into effect there. That's cool, C. Strachan. Well, listen, C. Strachan, if you run into troubles in your glorious path to saxophony victory, we have several help sections in the Discord. So check out the Discord. Anyway, you're on there. Okay, yeah, that's right. I've seen you in there. Well, this is just me plugging the Discord in general. You can check out the Discord. Lots of cool people there. Lots of good help sections there. Okay, so that's the plan, right? But it's easy enough to talk about a module testing module that has 6 channels and all 6 channels can work as I/O. It's harder to actually implement that. In order to get signals into the 3.3 volt systems, 3.3 or 5 volt is what we're actually settling on. We're settling on a 5 volt system. I'm not even going to read that aloud because I think just spreading misinformation, even if it's a joke. Anyway, so what is this? We let him drink resin. Oh yeah. I didn't drink. I chugged resin one day as a challenge. I actually took the bottle and I upended it. And I'm fine. I'm a little bit plastic. No, we bought a UV printer that was supposed to be broken, and it seems like one wire was loose, which means I got a resin printer for a third of the price. And I have clear resin that I've been using to quite some effect. The Fallout power armor that turned out way too perfectly, built from game files. I would love if I was a miniature guy, if I had a lot of miniatures. I mean, I am a miniature guy. I'm 5'9". But if I were like one of those dudes that did a bunch of stuff with miniatures and, you know, spread misinformation on the internet, you know, that kind of person, I would love to like embed LED stuff into something like this, because you could have the eyes glow on this Mark, or what is it, XO1 power armor. That would be really cool. But anyway, I'm not a miniature person. I do real stuff with things nobody understands. Yeah, this turned out really, really well. This is just a test print. But I got the resin printer and I set it up. And the thing about resin printing, you'll find, is you need to have a dedicated space. You need to have a dedicated space where you can put down silicon mats, where you can have freedom of movement, where you can be standing while you're working on everything. That's really important for resin printing, because resin printing is very clean until it isn't. And then it's very unclean. And I ended up, because I wanted to test the whole thing, right? So I had it sitting on my computer desk next to me, printing stuff. And I was like, this ain't so bad. It only smells a little bit. Well, it's a slight smell, and the slight smell gets to you after a long time. So I decided to then put it into a 3D printing enclosure, like a hood that I have. It looks like a grow chamber, but it has a Creality label on it. So I put it in there, but the problem is you have to tilt the whole printer to get it to sit in there. So I decided to put this thing into the 3D print hood that I had set up and everything with, like, you know, air handling stuff and all that. And I did that, and all of the resin went over the back of the printer. And then I had to take apart the printer again and clean everything again. Resin printing is extremely messy unless you have space to operate. And when it's printing, it stinks a little bit. So I set up a folding table in the other room here so that it's not in my way for the next thing that I need to resin print, which would be the water cooler for Burn the Subs. Materials breaking down. It's PETG does really well. That's soda bottle plastic. It's a non-stinky, safe plastic that you can use on an FDM printer, and it works really, really well, especially for my purposes, which is mostly doing engineering bracketry and stuff. I need things to be kind of strong. So you can run over PETG with your car, and your car will break. Anyway, what's going on here? Let's flip over to EE instead of the mechy stuff. PETG is great when you have problems with it. Just turn the temperature up. That's been the lesson with PETG. For me, everybody else in my Discord will argue with me on that point, to the degree where I will have a problem and I'll share it, and everybody will tell me that I need to tune this or tune this down or take this temperature down, and I go, nah, and I turn the temperature up, and then everything works again. Multiple times that has been the solution. It's not sticking. It's not sticking to the bed. It's not sticking to the bed. Maybe I should calibrate. Maybe I should do that. Maybe I should turn the temperature up, and I crank it, and then it works. All right, so anyway, what's going on here? What is this infernal circuit that I'm looking at? Well, if you guys know schematics, then the following explanation is going to be a little bit, I don't know. Everybody should know a little bit about schematics. Schematics are hieroglyphins. Lawless. Hieroglyphics that are supposed to communicate circuit connections to engineers. So the symbols are the components. The little triangle here is a comparator. It has a positive and negative input. That comparator input corresponds to pins on, I think I have one open here, don't I? Do I have one of those open? I might not actually have a data sheet open. Anyway, it's an 8-pin device. So this thing right here is an 8-pin device with a little notch in it. Now, because electronics evolved from vacuum tubes, that little notch is actually representative of a break in the pins. Because I have vacuum tubes and I bring them out to display, but on a vacuum tube, you have pins that are in a circular pattern around, or coming out of the bottom of a glass tube, right? They're in a circular pattern. The way to denote pin 1 is you just have one of the pins missing. So if one of the pins is missing, then you have a gap, and a gap symbolizes where your pin 1 is. And you go anti-clockwise around to count the pins. So this is pin 1, pin 2, 3, 4, mind the gap, 5. Now I know there's another gap here. That's just one of the I don't know, it's one of the necessary elements of working with square chips. Square chips allows you to sort of standardize things a little bit and have standard spacings and have standard layouts and stuff that are a little bit less. I think I need a surprise nap. What does that entail? So you have a break as symbolized by a notch or a dot, or sometimes a chamfer on one end. And then you have pins 1, 2, 3, 4, 5, 6, 7, 8. So that's how the pins are counted. And so inside of that epoxy package, you have 2 op amps, and each of these op amps takes up 3 pins. Electronics exists inside of packages, and you have multiple different packages because the silicon die just uses these little bond wires to connect to the pins. Don't know anything about this field? Last week got recommended a YouTube video from a channel called Nathan Builds Robots about microfibers from carbon fiber, blah, 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 embedding in his skin. Yeah, you want to use good filtration if you're working with carbon fiber, you know, cutting it and stuff like that. I am a de facto expert in that sort of thing, and I take precautions, but I also don't work with carbon fiber a lot. If you are working with carbon fiber on, you know, any sort of a regular basis, you need to do full respirators and protection and stuff like that. That's yeah. Usually entails waking up with a keyboard imprint on my face and there's random characters in chat. Neat. So all these symbols represent different elements in a circuit. A comparator or op amp is designed to compare 2 voltages within its range of voltages and give you an output that you can then scale. And that's what we're doing with this particular circuit layout. You can do a lot of different things with op amps too. You do integration and weird mathematical stuff. Electronics is math. The resistors are symbolized by these squiggly lines. And that's because in the days of yore, in the days of yore, a resistor was just simply a wire that was wound around something. I don't know how they avoid. I mean, sometimes resistors are like zigzag wires back in the day, way back in the day, when they were operating on literal like cutting boards by screwing electronics onto stuff. And you had like screws that were halfway in that you would put a wire in between. Basically, the resistance was achieved through the length of a slightly more resistive wire. So the length of that wire was going to be a resistor. That's why we have a zigzag. Now the Euros are doing stuff in much easier to draw ways. I often draw resistors as zigzags just to trigger people, just because it's very sloppy. But the Euros have just a box as the resistor, a box with 2 leads coming out of it, because that better encapsulates what a resistor actually looks like. We have a capacitor, which is symbolized by 2 plates. Amelia Gillette does things a little bit badly here. I think her internal libraries use that symbol with the curved plate. The curved plate is actually there to denote what's called an electrolytic capacitor, which has polarity. The capacitor that's actually used in this circuit is a ceramic capacitor, which does not have polarity. With polar capacitors, you just have to be careful about what direction they're in, where the positives and negatives of the potentials of voltages going across them. This all sounds a lot more complicated than it is. I just don't have small words to describe these things. There's better ways to explain this stuff in layman's terms. You guys are welcome to go search for it on the internet and read an article that probably puts it in better terms. But what we have here is a special symbol. This special symbol is called J6, as in jumper 6. You see IC for labels, R for resistor, C for capacitor. Sometimes these labels will be on circuit boards themselves, and you can actually relate the schematic to the actual circuit board and where the locations of components are by using these R's and C's. That's the good way to do it. So R's and C's, I typically don't put values on my schematics, but it's nice that Emily did. I think I'm supposed to say Emily. I read it as Amelia because of the accent over the E. What we have is we have a summing op-amp, a summing inverting op-amp. Now that is still one of the basic op-amp circuits. If we go over here, we can scroll down to where they have non-inverting summing and inverting summing. So basically the ratio of your R's determines what priority in summing they have. I don't know why they seem to have broken it down to not relate to the R's, but VS is minus the sum of the V's. And then they didn't pull the R's into the equation. Why didn't they do that? That's weird. I don't know. In other circuits like this, they'll actually tell you what the relation is. But this one seems to assume that you want all of these to be the same resistor. So what's going on here? Nothing. Okay, hold on. Wait, where's my browser window? So what is happening over here? Close this. What is happening over... Where did that go? Did that zoom out? I think that zoomed out for me. What an annoying thing. It zoomed out for me. Oh no, this isn't the one that I wanted to use. There it is. So what's happening here is we have a signal coming in from our headphone plug, which is what J6 is, as in jumper 6. You plug in a headphone plug and it connects us to this line here. And this line here has a voltage potential, in this case, -5 to +5, but it's really -10 to +10, right? We have -10 and +10, and that will get inverted and scaled. So if we're inverting it, in order to do an offset, we actually want to add voltage to it. And what we're doing is we are adding a -10 volts. And what that's going to do is that's going to shift our potential input down into the negatives. So now we have a fixed -10 as our starting point, and we can go positive or -10 volts from there. If we go positive 10 volts from -10, we're at 0. If we go -10 volts plus -10, we're at -20. Now, this is well out of the range of all of our electronics, but that is compared to ground. It is then flipped, and because we have a 1-to-3 ratio here, it is divided by a third. It's multiplied by a third. It's a third of it gets through. 2/3 of it is canceled out. I don't know how you want to talk about this. Why are we having this talk? It's way too personal. It gets knocked down by a third. So it is now 0 to 3.3 volts. And then it's flipped. So it becomes 0 to -3.3. It gets flipped. So it's 0 to positive 3.3 volts. 1/3 of what's coming in. Although I guess 20 volts down to a third. Maybe this is just for 5 to -5. Either way, we've gotten it to work with all kinds of different scaling here. But that -10 is literally just there in order to shift it down on the number line and produce a positive voltage on the output. So if we give it a strong negative signal, this thing is strong positive. If we give it a strong positive signal, this thing is at 0. Easy concept. It gets a little complicated in the math. But yeah. And I guess the ratio of this, I don't know what that's doing. I don't know what that's doing. It might equate to the amount of current. So we've implemented this circuit, but instead of putting a 33 kilo ohm resistor on it, I have put a 100 kilo ohm resistor. Actually, not here. Over here, I've put a 100 kilo ohm resistor on it, and then I also have a little bit of an output resistor adjust as well. We have more adjustments on this thing because it's going to be a piece of lab equipment. So we can have all kinds of adjustments in it. Oh man, that was complicated. Probably lost all my viewers. What I was able to do with the Teensy audio tools is output a waveform, put it into our boosting circuit to get it to be ±10 volts. So this thing is outputting a waveform at maximum amplitude. Let me turn this all on so I have a visual example of what's actually going on. So I have this really nice expensive scope that I bought for like a big birthday. Nice expensive scope that enables me to open an intranet page and show you guys in real time what waveforms are present. So if I turn on the microcontroller, it is going to output a bunch of different waveforms individually on the channels. Turn on my power supply to 12 volts, make sure we're not using too much current. I think we're good on that. Let's get the second channel out of the way, and I can just show you guys by poking in. Second channel out of the way. This one's channel 1. Board's looking complicated day by day. Yeah, I know, it's multiplying. How's it going, Sir Hiss? So here we have outputs. I have triangle waves, which are plus minus, I think it's about 3 volts. Zoom in on that a little bit. Oh, we're not selected in channel 1? Nope, turn it back on. There you go. Yeah, about 3 volts, 3.3 volts, plus minus. This is maximum gain for this audio amplifier. So again, like if you're building a guitar panel, guitar pedal or whatever, this is beyond line voltage. Line voltage is plus minus 1 volt. You guys crave this stuff. Well, it's good to know. So that's channel, the first channel. Second channel, we have a sawtooth. Third, we have a sine wave. Fourth, we have a voltage level. We have a DC voltage level. That's kind of going to be an important thing if we're doing control voltages. Fifth, we have the sawtooth again. And then the sixth channel, we have a square wave. So what I'm doing is I'm outputting maximum amplitude waveforms so that we can tune the boosting channels over here. And what we have are, well, nothing. Oh yeah, nothing's really hooked up right now, is it? This one's hooked up. This one's a sawtooth. And you can see it's blowing out the oscilloscope. If I put it down like that, you can see we're just tidally getting all the way up to 10 volts. Tidally getting all the way up to 10 volts. So I think the rest of these channels aren't being used. I don't have them hooked up right now. Yeah, we're not really boosting anything with these. They're just kind of floating. So I've got all the waveforms here. I'm outputting them here. I don't have an output hooked up. I don't have the plugs hooked up yet. But what I do have is I have them going into what's called a mux. A mux is just basically a solid state switch that can be digitally operated. So I don't have the microcontroller hooked up to the mux. We'll do that in a little bit. I need to hook up a couple digital pins here to the mux, and then we can flip the mux between its 8 inputs. Previously, I had all 8 of the inputs hooked up to the 6 channels, and then I have 2 extra channels. One of them I want to hook up to positive 10 volts. The other I want to hook up to negative 10 volts. And that way we have our full spread of voltage levels that I can then put into our receiver. I can only do 2 channels of receiver. If I get slightly more complicated stuff, like an audio codec, then I could do 8 input channels. I could do 8 input channels. We don't need 8 input channels on this device. This device is mostly going to be running outputs and then observing probably 1 input, but I can do 2 if I really need to. So we have a left and a right channel on this thing. It's hooked up to the same bus system as the other I2S outputs. I actually have available extra I2S outputs that I'm not using. There's 2 more outputs on this line that we're not even using. So we'll have 6 I/O, input or output, and the output is driven by the I2S channels. The input is selected between channels. And we use the mux in order to select it. And then I have trigger channels, DC trigger channels, that can be done with the, that can be done via the digital pins using a transistor. The problem is I can't put a DC voltage into this device. We took the capacitors off of it so that it didn't cut DC power, but this needs an AC signal, and it's not that good at measuring a DC voltage level. That means that my calibration can't happen unless I turn it into a wave or something, which I'm not going to do. What I'm going to do is we are going to add an I2C ADC that works in the same DC voltages as this thing inputs. This thing inputs 3 volt peak-to-peak signals. So I think what we have is this thing hooked up to be like, is it 3 volt peak to peak? I think we have it at on the positive end of the number line, and we have it 0 to 6 volts, a little bit below. I think it's within its usable range, whatever we have going on here. We have it scaled to within its usable range. I will observe that range with this, and then I guess from there we can calibrate everything. So this is going to be a DC device, so we want it to exist with all the DC stuff all the way up here. We're running out of room on this board, so I've had to kind of move stuff off into the corners. A lot of the stuff that we've tested before is kind of parked over here. And eventually I'll have to get that encoder running. Got a lot of work to do. I got a lot of stuff to set up on this to get this comprehensive piece of test equipment running. And then when it comes to building it, I think there's going to be a lot of different modules sort of hanging off of the back of this thing. You know, like I'll have to have like a power circuit board. It's all going to have to be on separate circuit boards. So I'll have to have separate circuit boards that are all connected to each other and just hanging off of the back of this thing. It's going to be a big module, big complicated module. I have to pee. I have to use the bathroom. We're going to go to a BRB screen real quick. I got to use the potty. I'll be right back, chat. When I get back, what we'll set up is the -10 reference. We'll hook that up to the multiplexer, the whatever you call it, and then we'll get the microcontroller to operate this stuff, the I2C and the MUX, and we'll see if we can jump in on different channels and observe them. So where's this? I need to turn off the scope because I need to get that on screen. There we go. And then we get one of these up. Not set. That's not set as overlays. It's one of these guys, like this one. That's my blood glucose level. That's not the one I want. Let's see. Oh, don't need that. No. Let's go back to where it was. No, that's not it. That's not it. That's not. Who's in the booth today? Get that out of there. Do one of these, and then I'll hit play on the music. I'll be back in just a second. All right, I'm back. Silence in the hive. It wasn't silent. I had music on for the YouTubers, or the YouTubers don't get the music. It's only for the Twitch people. Okay, so we are back. I's back. Yeah, see how the Twitch people are dancing? They're all dancing. So the way we hooked this up before is we had a waveform coming out, one of the waveforms coming out of here, getting boosted, going to the mux, going to our tamping circuit, and then going into the input, and then that input was then being filtered or funneled out to an output. So we could see whether or not our input was clipping, and we know that our output is at the highest gain that it can possibly do. So I was able to adjust this circuit here to be within bounds of the audio input. Now we need to do like DC analysis, and that's also how, well, that's not how we're gonna detect gate signals. Gate signals will always be going into digital inputs. Yeah, so now we need to detect that voltage level. Now, because the amplitude of that voltage level is, sorry, it's plus minus 3 volts. Plus minus 3 volts. So I grabbed this little goober right here. Now wait, it's plus minus 3 volts? No, it's 0 to 3 volts. It really should be 3 volt peak to peak. Oh, it's 3.7 peak to peak, but we're not going into the negatives with it. Even though it hits the high pass filter of this thing and gets turned into... Is that one not connected? What's going on there? That's a little weird. Wait, why am I losing my... Why is that just 3 volts? Oh, because that's where, yeah, this would be the pin that... Oh, okay. What? Strange. Oh, because it went DC on me. Why'd you go DC? What happened? I bumped something. Something got bumped. Yeah, we're not outputting anymore. It didn't much care for me connecting the probe there. Oh, you guys can't see the scope. Turn on the scope. Bonk. So let's see. We're all hooked up, right? Yeah, you're hooked up. You got a ground. There it is. So yeah, our signal going in is 3 volt peak to peak. That's been adjusted and all that. So we have a 0 to 3 volt input. Actually 0 to 4 volts almost. 3.8. If I tamp that down a little bit, we would not have to use the I2C input. If I tamp that down to be, because I think 3 volt peak to peak is the usable area for this, although we've pushed it a little bit and we're getting our, yeah, here's our sawtooth. If I were to disconnect the output here, hold on, let me get tweezers for this. Or tweezers. If I disconnect the output here, okay, so that sawtooth is still there. We're looking for whichever channel goes blank here. Maybe this one. So this will put the sawtooth, yeah, there we go. So this channel is the output from the input. It's the one that I looped back, basically. And so this is getting a full spectrum. It's going from +6 to negative, or +3 to -3. And our input signals are going from, oh no, that's the voltage reference, are going from 0 to 3 volts. I wonder if we get more amplitude on this thing if we had it go from positive to negative. No, but this can only do 3 volt peak to peak and a maximum of 6 volt input. Because we looked it up. I've got data sheets to back me up on that. So yeah, we are where we need to be. What we need to now do is observe those voltage levels. The inputs for Teensy 4 are not 5 volt compatible. That's why I wanted to bring this thing into the fray, because this thing can go up to, I believe, 6, it might be 6 volts. But if our power coming out of this thing is from 0 to 3, we can just route that into the Teensy. I mean, it's a little hotter than 3 volts, but I think we can I think 3.8 is the maximum. Let's do Teensy4 analog input level. Never believe the AI when you're looking something up like this. Don't believe that AI. It'll just lie to you. If your question is a little bit more eclectic than just the very basics and simple stuff, then it will lie to you. This might be a factual answer, but I just don't take that at face value. We can look up just the basic web page for the Teensy4. We can see that right here it's quoted, analog input range is fixed at 0 to 3.3 volts. On Teensy 4.0, the analog reference function has no effect. The analog pins are not 5 volt tolerant. Do not drive the analog pin higher than 3.3 volts. Well, looking at our scope, we're looking at our scope. That's not right. Where is this error coming from? Who's doing this? Who is this doing this symphatic type of alpha beta psychedelic funkin'? Is it wiggle wire? I hate wiggle wire problems. They're always very annoying. Wiggle the wires. Wiggle all the wires. Wiggle the wires. Why do you hate me? There it is. Okay, so there's our output. Our output goes to 3.8 volts, which is the maximum input to the Teensy4. I'm a little concerned about that. I mean, I guess I could pull it back a little bit from maximum amplitude, or I could tune it back a little bit from maximum amplitude. What, it's a PCM 1808 or something, right? Yeah, PCM 1808 data sheet. I may already have it open. Single-ended analog 24-bit. I mean, we do have plenty of bits. Low cost, single chip, stereo analog to digital converter with a single-ended analog. That stuff. Max ratings, all the jumper settings. Good God, this is a lot. We're doing a lot. Absolute maximum. So this is not the readable range. This is just the maximum. This is the range that you can get to before you blow up your device. 6.5 volts analog. We're giving it 5. We're fine there. Analog input voltage. So negative 0.3 volts or the maximum is VCC plus 0.3 volts, anything that's below 6.5 volts. So we are not giving it a negative voltage. It's a little odd that it would say that, because shouldn't it be able to go well into the negatives, because it's got that DC, it's got the capacitor in there blocking DC. VCC, which is which one? Which one is, VCC is analog supply voltage. So that's 5 volts. So 5.3 is the maximum input. We found that anything over what we're giving it right now clips. So anything over 3.8 clips, but I suppose I could take that down to the usable range of analog input. And we should probably just put our money where our mouth is, since we're running almost 4 volts and the maximum input to the Teensy is 3.8. So we are at the ragged edge of what will not damage our stuff. But we can take a DC voltage from here at maximum amplitude, or we could just assign DC voltages and see what they come back on the I2C reader, and then we can kind of tweak things so that everything is within specifications. This is a lot to worry about all at once, huh? And that means we don't need to have another I2C channel, which is, I guess, nice. I guess that's all right. I was just going to balloon this thing out of control and just have all kinds of devices hooked up to it. But I mean, we need to save our computing cycles where we can, because we have a lot of stuff going on. So for right now, let's get another analog channel coming in here. I will arbitrarily choose analog pin number 14. So analog pin number 14, let's see what it's doing here. Why is it so far away? Wait, huh? Oh yeah, there is a pin after 14. Okay. It's pin 13, but that's serial clock. Miso, Mosi, and chip select. So I do need to preserve serial for the screen. So SDA and SCL, SP diff, I don't think I'm doing anything with. So pin 14 seems to be clear. So what we'll do is have, I haven't done anything with pins yet, so I might as well put them, I don't even know where. I guess I'll put them down here after end automatically generated code. Actually, let me look at some code that I did recently and make sure that I'm staying within. Do I have anything open for that? Oh yeah, Teensy4 stress test. Yeah, I haven't gotten anything really working with that yet. So there's, oops, one more slash on that. I'm making sections for future blocks of code on here. A in V test pin 14. Yeah, we're not doing this test right now, so I'm not going to put that in there. Those are my pins, those are my settings, and so in settings we have serial speed. So speed, 115200. A in V test. So down here, pins. And then serial start. Damn, I forget how to do all this stuff because I haven't coded like this in a while. Five test, blink, tone, happy birthday, siren, large text demo. None of this stuff is relevant. Let's just open up like a recent project and I can just see how I do serial and stuff like that. God, it's funny that I don't remember. Why is this thing? Oh, it's only got 140 kilobytes. That's why I was like, why is my audio input out of memory? Network. I don't think this is going to work. Oh, it does. Never mind. That's not the right one. I recently did a bunch of work on my file server, so things are a little permission-y. All the permissions are all messed up. Mercwheel was a very extensive project. We did some very complicated things with that. That's why this project doesn't scare me, because we set up an entire engine to emulate a Bluetooth low energy device connecting to the host. We fooled the host into thinking it was connecting to a Bluetooth low energy device, and then had it press buttons for us, which was a really weird thing to do, but we got it working. I'm trying to think of where I had just like a normal Arduino project, you know? Here are some older ones, but I guess I can jump into some of these. Like if I do packet test, maybe. That's going to take a little while to open up. I just want a little example of code so I can remember some of these stupid things that I forget about. This looks a little bit more complicated. I don't know if this is done the way that I want it to. This is using software serial, which we're not. RX and TX pins, software serial, 16, packet, power commands. There we go, serial begin. Okay, so serial.begin. And then that would be sir speed. And that's all we do with serial. And then pin mode, that's what I was looking for. Pin mode, you have to assign these because they're generic, they're IO, they're inputs or outputs. So pin mode A in vtest input. They may be called analog pins, but that doesn't mean that they can output an analog voltage value. Unfortunately, that's a misnomer, and it's kind of a, might have been a translation error, but it's something that confuses a lot of people, is that you can't output an analog signal. If you do use the analog output function, it outputs a PWM, and you can then apply that to a filter circuit in order to turn it into a voltage level, but it will not intrinsically output a voltage level from the microcontroller. Probably would have saved a lot of people a lot of time if they either named it right or had those pins able to do that. Now, some of the more advanced microcontrollers nowadays can actually do like audio outputs and stuff. So there's a whole world out there. So what do we want to have in our main code? I don't want to use delays. I guess we're just going to hit this with just a shitload of serial prints. And if I do that, then it's serial print line analog read, and then A in vtest. And that's it. That's all we're doing. I don't know if that necessarily works like that. I don't know if I can do that inside of the serial print. So let's just, instead of doing that, I'll just read it into a variable. Is it, so it's 0 to, what is the resolution of the TNC 4.0? What numbers are we getting back out of our analog reads? Analog signals will be converted into digital with a precisely defined voltage threshold for logical oversight. That's not it. 14 pins can be used as analog inputs for reading sensors or other analog signals. Basic analog input is done with the analog read function. Default resolution is 10 bits, 0 to 1023, but can be adjusted with analog read resolution. The hardware allows up to 12 bits of resolution, but in practice, only 10 bits are normally usable due to noise. Most advanced use is possible with the AEC library. So, I mean, technically I could take that voltage in with the audio tools as well, but we're not doing anything audio with it. We're just going to print it. So what I'm going to do is read that into an int. An int has plenty of resolution. Vin is equal to analog read of that. Serial print line, Vin. This is as simple as it gets, and it's going to completely destroy the serial port. It's way too fast. Doesn't really matter, though. We can just do this. So what'll happen is it'll output all these waves, and then it'll start punching the serial port like it owes it money. And then we'll be able to look in our window, and we'll be able to see all those values. We could even plot them if we want. The thing is, the input that we have is currently a sawtooth wave. So I can take over that input, and I can put a 0 to 10 volt signal into it that is more analog. I also have a half amplitude DC output on one of the channels that I could use to read back. I think that's all we need. So I'm going to upload this. And in the meantime, while it's uploading, I'm going to hook up channel 14, pin 14, to this right here, which is not in a very convenient spot. mean, it does go over to here, but I can't really get it over there. It's impossible. I'll use a yumper. Use a 3-dimensional yumper. Okay, class. USB serial class has no number named print line. What? Oh, println. Print line. This is the thing that the chat IDE usually catches. And it always annoys me because I don't get to make those mistakes. Chat will correct me and then it'll be like, well, if you let me fail. People who don't know about this stuff can get a nice little example. All right. 1 or 2 little hang-ups. Oh, I have to press the button on the boop. We have to make sure that that programs. Where are the teensy? Oh, here it is. No, that's not it. Well, let me close this because this will get confused by the serial port stuff. There it is. Press the button on the teensy to program. Boop. Bada bing. Okay. So if I observe, well, hold on. If I open up the serial port, there's a number what represents our voltage level. Now, right now, they're all in the 8s because we're not giving it a steady voltage level. Right now, we are giving it what we see here on the screen. We're giving it a sawtooth, and apparently it is constantly falling at about the same spot. The other thing that I could use to display this is we could actually open up the serial plotter. Where's that? Serial plotter. Yeah, this is what the input looks like. That's a kind of a strange input. I don't know how that corresponds to the, whoa, to the timing of everything, but oh, I see. It went blank. Let me make sure that I'm on the right pin. Yeah, I'm on the right pin. Hold on, wait a sec. This goes to there, yeah. Oh no, I think we might be on the wrong pin. We might have been reading noise. Why did that light turn off? Reset that. And let's see if we can get this to actually output. What's going on here? The plague of wonky signals. That's not what we're looking for. We shouldn't have a constant voltage level. We should have a wave. Yeah, it's this that's not outputting. Any channels working? Yeah, all these channels are working. I don't know why it gets squirrely like this. It like messes up and gets all weird. And it all depends on whether or not I accidentally hit this thing with a ground signal from my hand. Maybe it's the 3 volts isn't quite getting through. That voltage regulator is getting very toasty. All right, now we're back. And this is getting, that's getting a triangle wave. This thing should be reading so fast that, okay, now we're getting a varied amount of data. So if I open up the serial plotter, look at that. So, so we are clipping, but we're getting our triangle wave all the way back in. How cool is that? Oh, that's super crazy. I can't believe we're reading an entire triangle wave. We're just using the analog input to do a DC read. But if we take that peak to peak down a little bit, just a little bit, then we'll be able to get full spectrum reads on our low and high voltages, and we'll be able to get that scaled in. That's cool. Of course, there will be a bit of like a feedback loop going on in that I'll need to adjust Oh, let's see. If I take this down, then I'll have to boost up the 10-volt sweep, because we've got a couple different, what we've got going on right now is, where am I going to put this? Let's expand our canvas here a little bit. Take this. Take, oh yeah, we're not doing that. This. We take one of these. And I need more space already. So we're going from here to here. And we are reading that after the mux. I'll do the mux as like a little switch. Channel mux. Then that goes into another circuit here. Oh, I gotta stand up for a bit because my butt broke. I know how crazy it is that we're able to do this. This is so this is so crazy. This microcontroller is so fast. All right, so 8-channel mux, 3-volt peak to peak, and then that goes into here. Well, 0 to 3.8. And then this one is plus minus 10. I'll write that above. So plus minus 6. Or no, that's plus minus 3. And then this one's plus minus 10. And then we have 0 to 3.8 over there. And then this goes back where it then goes to another signal that brings it up to plus minus 10 volts. So we're basically feeding I2S directly back. And actually, instead of representing it that way, maybe I can do oh god, it's hideous. We're feeding I2S like this. And then we're feeding it back in. And then we are also reading, where are we reading from? Where are we even reading from? So this is just how we're determining whether or not the audio is clipping, but then our analog read is actually hooked up here. So yeah, this is a very weird system. We're able to basically see what this thing sees in I2S by looking at what's coming out here. And if what's coming out here at maximum amplitude is clipping, then we can see, we know that we're actually overdoing it here. We're overdoing it on the reading side. But when we're reading from the 0 to 3.8 here, we're getting a little bit of a clip. So if we turn this down here, turn this down, then this is still able to function at 0 to plus 10, but it's going to be reading a little bit more limited, and it's going to be lowering it here as well. Super weird, but let's adjust it here and see what happens to the rest of our system. Because yeah, this analog read is going at super duper fast speed. We're only really supposed to be using it for DC readings, not for recreating a waveform. Funny, though, that we're able to recreate a waveform because our analog read is the only thing that our loop is doing, and our loop is running at 600 megahertz. Or what? It's ridiculous. You can overclock this microcontroller to a gigahertz. You can have an entire Celeron inside of your microcontroller. It's so weird. I wonder what it can run. It could probably run Doom. It could probably really decently run Doom. We were running like Descent 3 on a gigahertz, weren't we? There's our sawtooth. Although no, I've shifted it too far down. It's clipping on both ends. So yeah, let's get the clip up there a little bit, and then we'll adjust this one, which is our overall amplitude, until it do not clip. There it is. So now it's not clipping. It's a little chaotic just because the serial read is not synced up to show that triangle wave, but that's a triangle wave. So now what does that look like to our other elements of this system? So if I look at the output that's boosted, that's this right here, this should be plus minus 10 volts. And it looks like it pretty much still is. And it gets a little squirrely when it changes directions. Our VPP is at 20 point something odd volts. So what if we give this a DC value of maximum amplitude? What does that then become? This file's now just gotten huge because I've added all these pixels to it. So, not looking at that. Now we're just doing DC1, amplitude 1. And actually, before I do that, let's hook it up. Let's make sure that we're on the right channel for that. Serial Pluter. And I can switch channels over here. I'm basically acting as the mux. Later on, we can actually turn that into... Oh, of course, it's all fucked up. You know, I poke the board once, and this whole thing goes to shit. Let's reboot the micro and see if that fixes it. Yeah, see, that fixes it. Yeah. There's the sine wave. Look at that sine wave. That's awesome. That's a nothing burger. That's a triangle. Like, this is our output, so our DC level should be somewhere around here. We should have a half amplitude DC level. It should be more stable than this, too. That's not it. That's not it. Oh, this one's negative. What the? Wait, how is that one negative 5? Huh? That should be a positive DC offset. That's a negative 5. Oh, because amplitude is half, and I am observing it at... Yeah, that's right. Okay, so that is correct. Although negative amplitude of 1/2 should probably be in ground instead of negative 5. I'm looking at this on the scope. But then why are my analog reads all over the place? Oh, because we've zoomed way in. So it's 765 out of 1024. My math is not on me. Hold on, calc. Well, 1024 is going to be like 500 something, right? 1024 over 2, 512, yeah. So that's not quite correct for our half value, but that's what the auto calibration is all about. So if we set the amplitude to 1, it's still going to be as chaotic of a plot. If you look at it as numbers, you can see it's hovering around 750, 760. We'll have to do like an averaging. We'll have to take like a big average. Or we could even take it into like a Kalman filter if I really want to be fancy. But since we're not constantly reading it, I don't think I need to pull those systems into use. I might be able to do like an RC filter on it or something. But let's make our amplitude 1. Where are we? ANV test, DC1, amplitude of 1, upload the code. Did I hit it? Did I hit upload? I think I hit upload. There it goes. Bum, 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 bum. We're giving up a little bit of resolution. We don't have a full spread 0 to 1024 coming out of the thing. And 1024 seems a little bit inaccurate, although the teensy purveyors tell me that that's plenty of accuracy. Oh, so with the amplitude at 1, I'm almost reaching 10 volts. I'm very close to negative 10 volts. And we are very close to negative 1024. That's pretty cool. Will's going crazy about something outside. I don't know what it is. She's all hyped up about something going on there. Why only 1 amplitude when 2 is twice the price? What? What does that even mean? So here we're at 10 something or other. What if we take it to 0? This is as little voltage as it can get. What's up, Malzum? How's it going? Next, we're going to try to get a negative 10 voltage reference, and we'll hook up the mux once we get a minus 10. Hey, thank you very much, Kubus Moore. I wish I was a little bit more confident about my content. So this is interesting. We're at half of our notable range when we're at DC amplitude 0. Oh, because this goes to negative 1. Okay, so we're at about 512. Oh, what? An obscure cut from Contact. Oh my God. That is a deep cut because I don't remember that at all. You would have had to just watch the movie in order to get that one. So now we take it to negative 1, DC amplitude of negative 1, and we should be at 0. That's cool that we're able to use the internal Arduino inputs, the Teensy 4.0 inputs. What exactly are you doing? We have this massive loop that we are dropping our microcontroller into, although the loop is its own doing, in order to calibrate. I want a calibration to happen because we're trying to build a device that's going to be measuring voltages on a modular synthesizer. So from about 9 to 12, which probably means that we could shift things down a little bit, but as long as it's within its own usable range, we've got a good thing going here. I don't want it to clip at plus minus 10 volts. And I guess I could bring it in a little bit more. I could make it actually tolerant of plus minus 12 volts, but I don't think we're going to really need it. As long as we have kind of a functional range that things can sort of go out of, we can say, oh, that's clipping. And then, yeah, I can adjust from there. Because I don't think any of the synthesizer stuff that I'm building recently uses 12 volts. But that would just be a matter of recalibrating things a little bit too. Ah, this is cool. we're going to be able to make this thing internally calculate what its what do you call it, scalars are in order to create accurate voltage outputs. And for the layman, what's going on is I have a Teensy 4.0 that's running the Teensy audio tools. You can see here that it's at 10 volts according to my expensive oscilloscope too. Teensy 4.0 that's using the audio tools to output I2S to 6 channels. The 6 channels have waveforms or DC voltage levels on them. So right now what's going on is we are hooked up to one of the DC voltage channels, the fixed DC voltage channels, and it is outputting in this DAC's range, which is plus minus 3 volts, to our amplification stage, which is boosting it to a nice accurate plus minus 10 volts. That would then be output, and on those same output channels, we have a mux that is switched to the channel that's doing the DC bias. Then we have an de-amplification, a damping stage that's dampen it down to the input range of our ADC. And the ADC is hooked up to the same I2S system, only on the input line, and it is feeding back into the Teensy4. We also have an analog line from the Teensy4 connected to our damplification stage. So our damplified voltage value is being read by the Teensy4. In addition to that, the I2S system is plugging one of our 6 channels into the input, so that if I read one of these other channels, we should be getting, oh yeah, that's right, it can't do a DC voltage level. We would be getting the waveform, but we can't because it's this thing doesn't do DC. These will output a DC voltage level, but this will not receive DC. It's got a high pass filter in it that's killing. You got Yoda on the OLED. I really need to work with this VFD soon. I need to work with this thing and make some cool screen stuff, because that's gonna be how we run this whole setup here. Oh man, big stress test, you guys. Big stress test. So now we know that we can receive our audio, our voltage levels. What is getting warm up here? 5-volt regulator. That 5-volt regulator is necessary for this thing's systems. There's going to be, the power supply is going to be a mess. Speaking of, let's make a positive 10-volt source. So I need to find these chips. I need to find. That's crazy that we could get away with that with just a little bit of adjustment, and we're not losing resolution anymore. We've got our full range of values that we can output from that digital to analog converter. And then we're Gucci to throw this thing right back in to the microcontroller itself, not even to anything else. I'm going to click on this, and it's going to fucking blow up my computer, isn't it? Oh, image to an array. Nice. Yeah, there's a tool like this for the Noritake screens as well. Yeah. There's a tool for the Noritake ones too. Okay, next. Oh, really? You can adjust the bandwidth. I could up the analog range, but I don't know if that's really going to be necessary. Hey, what's up, Flask? We are representing negative 10 to positive 10 volts in 1024 bits. And for our amateur thing, I think we're going to be running into a lot of noise at those lower levels unless I actually break down and create a PCB for this whole thing, which is, boy, oh boy, does a PCB sound like a great idea right now in terms of organizing everything. But I think what it's going to be is just a big bundle of wires. It's just going to be a big bundle of wires. Okay, so now we need the LM4040 B10 to output positive 10 volts. So I'm going to need to make a little circuit for that. Let me power down this whole thing. this old thing. Let me power it down. I don't know what the weirdness is with the things failing. Like when I touch this thing, apparently I have enough ground noise that it blows up the whole system until I restart it. Have you ever worked at MPLab IDE? I don't think so. I don't think I have. Any of the other IDEs that I've used have been purely like I've been forced to use. I've had something that's needed a particular IDE to program. So I made this one recently. Let's make the positive power version of this. This one is a negative voltage creator. I want to create basically the same thing, but it needs to create a positive voltage. So I'm going to get the vise, little piece of circuit board. We can chop this thing up and we can make our own little positive voltage. Why are we being so negative, chat? Let's be positive. Yeah. Besides which, you know, nobody's ever really gone. I mean, nobody's ever really created a big bundle of wire project. Where the fuck? So 3 across. Let's kind of clean that up a little bit. And then this one uses all of the rows, and I need that so that I can label it. Yeah, so let's just get that a little tighter. And then we clean it up with the big file. The big file helps just make these nice edges. I'm nice, I'm smart, and doggone it, people like me. Am I on a mic cable? Why is this? No, I'm not. Okay. I make sure I don't squish the mic cable with my stool. Yeah, the file just lets me smooth out the edges. So, like, I haven't been... Yes, Stuart Smalley. I've been doing like a lot of analog projects, and they've been kind of like falling flat on their face, right? A lot of that stuff just hasn't really been working out properly. Moving back over to digital, even digital to analog, this whole board here has been going so incredibly easily and predictably. I mean, I say that now, everything's going to come crashing down later. It's going to get, the complexity is going to balloon out into just this giant beast. But the sooner I can get hardware done, the sooner I can get a whole device together that I'll be able to throw a program at until I have something that's able to actually, like, read and manipulate voltage values in a modular synthesizer. Even if I do just leave it up for me coding all this stuff and I have text displaying on the screen, it will still be far and away a successful project. But like with the analog stuff, I've been running into problem after problem after problem after problem. And then I go over and do this digital thing, all these digital things, and I'm like, how is this so easy? It's just so easy. You know, you run a little test code, you vet out that your functions work, and you just kind of roll with the punches from there. It's what I've been used to doing all the time. Like my whole career, I've been used to doing things this way. I don't understand how some engineers, and I don't mean you guys, nobody watching on Twitch would ever do this, but some of the guys that I used to work with, when they would be confronted with a problem, they wouldn't even consider the digital realm. They would go directly into analog systems in order to create something like a timeout trigger that went off when you move a wire in the wrong way. And I'm like, why would you not do that digitally? I know analog can do it instantly, but like with digital technology, you can do so much more scaling of what things do, and you can, you know, rewrite how things, I don't know, it's just strange. Is this the voltage reference? LM, what are we looking for? LM4040? Yeah, LM4040. That's not these. LM317. Okay, that's not the, this is the wrong one. Shunt resistors. 5-volt reference, 2.5-volt reference, 10-volt reference. I got a couple of these. I must have reordered them. Thought I was running out. So this is a 10-volt reference, and so this one will give us our positive 10 volts. which will be pretty cool. I don't want this thing to heat up. I don't know what causes the other one to heat up so much. What they suggest, well, they suggest you scale it with the number of amps that this thing is going to be using, and I don't think I'm going to have any amps on this because we're using it as a reference. LM4040, go all the way down here. Yeah, in practice, they have it with a 1K resistor going to 5 volts. RS is equal to VS. VS is where? VS is the input. 10 volts, or 12 volts, minus VZ. 12 minus 10, so 2. Over IL plus IZ. Well, it's high Z. So it's going to be 2 over a billion. Must be large enough to limit IZ to less than its maximum rated of 15. So if we say it's 10, 2 over, well, what's IL? IL. Oh, God. Might have to up the analog input resolution. So it's 2 over, and it's in millivolts, so, sorry, milliamps. Or are we 2 over 0.02? Which would be 100 ohms. That seems a bit, when we had 3K in some of these other ones. Where is that? This one here. We are quoted at 3K, 3.3K. I guess I'll put 3.3K in there. What's this one at? 1K. Which is the value from the example at 5 volts. I'll put 3K on it. It's going to get just as hot as this one, though, if I put 3K on it. And then we want this Zener diode to be facing towards VS. Facing towards VS, which in the pinout, it's a big data sheet because it's a big family of products. I see that's the scheme right there. It's looking like that. Okay, so I got that up, and I have my thingy, and I just need a pin header. Pin header! I don't know if I'm going to put the capacitor on this. Just a right angle 3-pin header. Bada bing. That's all we need. Well, that and a 3K surface mount resistor. Let me get that. 3K. 3.3. There we go. Nice common electronics. Nice common digital electronics. This is going to be Eurorack. It's not Eurorack yet, but we are doing, yeah, this is a Eurorack tester. So we're mainly going to be focusing on plus minus 10 volt as our max, not 12. And as such, I have, because I've built a couple mutable instrument circuits, I have these LM4040 shunts, these voltage regulators that produce 10 volts. So I can create plus and minus 10 volts. There's not that many Eurorack streamers. What are all the kids into nowadays? Because my buddy Julian is the one that sort of like twisted my arm back behind my back and said, "You're gonna do stuff in fucking Eurorack." And I'm like, "Oh, stop hurting me. Please, why don't you stop twisting my arm around?" And so he got me into the Eurorack stuff, because that's mainly what his system is. He's got a very minimalist system. What I'm going to do is solder 1 pin, and then I'll make sure that this thing faces straight up and down. I've gotten a lot of viewers that are interested in Eurorack stuff, and the thing is, our electronics channel does crazy shit, sort of. We do kind of crazy stuff. We get into very complicated things, so it's not just doing Eurorack stuff. Eurorack is just because a buddy of mine got me to do it, and I promised that I'd build him a synthesizer for nigh on 20 years, more than that. So it's about time that I learned Eurorack stuff. Why is this? Ugh, it stays molten just long enough for it to go out of alignment. What a bunch of piss. Violence among peers. Yeah, what's everybody else doing? Like, I would assume that somebody's out there doing guitar pedals. Is that good enough? Yeah, it's good enough. That's pretty good. That's pretty good. Owie, this thing is warm. I mean, essentially all this thing is a Zener diode, but it's a little bit more accurate than a Zener diode, I think. So it'll give us our exact reference voltage that we'll need in order to calibrate the inputs and outputs from the microcontroller, so that we know that we are accurately representing all of our voltages. Pretty cool stuff. One or two guitar pedal makers. But like, I would think Eurorack would be pretty ripe for streaming purposes. I guess not everybody has Hajiwo's philosophy of doing things within a minimal amount of money. Where did my resistor go? I spent all that time getting the resistor. Now it's gone. Where did my resistor go? It's gone. Oh, it's on my palm. My palm picked it up. Yep, LM4040. You already know this hardware? I didn't know nothing about all this Eurorack hardware, all the stuff that these Eurorack freaks have been using in order to make their electronics, but I've been slowly building up supplies of everything. Oh, that's cool. Watch the guy from San Francisco that winds pickups and makes pedals. That's cool workshop content right there. You know, we try to be chill, and then I don't get any viewers, so I go back to shouting at everybody. That's just how it goes. I'm gonna have a chill stream where we work on electronics, and then everybody's like catatonic. All right, I guess I'm boring. If I had more projects to build, we could do ASMR soldering, but visual ASMR soldering. But, you know, I don't want to be fake to you guys. That's like my biggest fear, is being totally fake. You have certain streamers, certain, yelling is ASMR. You have certain streamers that are out there making all the booming noises and doing all kinds of wacky shit. I don't want to sell you guys short with that. I think we're going to be hooking this up in exactly the same way. It's just that this might be facing a different direction, because we need the squiggly end to face. Yeah, this needs to be 180 degrees from where it is right now. I am gaming. But have you also streaming? My community gets to hear me get my geek on through you. Wait a minute. What does that mean? They should watch me directly. So yeah, we're gonna flip this part 180 degrees, and then it's gonna become our positive voltage source. And I'll make a label for it, because if you don't label stuff like this, you'll never know what you've built 6 months down the line. 6 months down the line. I guess I will get a capacitor for it, just to be nice. It's probably going to heat up just as much as its buddy, though. That's the thing that concerns me, is that they're both going to get super stupid hot. I don't need you right now. I was explaining to another streamer's viewers what exactly we were doing, which requires a lot of theory work for electronics. So this stuff is very straightforward. Building a thing that tests stuff is very straightforward, but not everybody knows about Eurorack, and not everybody knows, you know, what goes into some of this stuff. So like op amps and things like that. Have I neglected YouTube, or is nobody chatting on YouTube? I think nobody's chatting on YouTube. All 3 of my YouTube viewers? Yeah. It's just the comment from when I BRB'd. A BRB'd. So basically this is flipped 180 degrees. That's important because the symbol for a diode is an arrow into a block, right? You have an arrow that goes into a block. The Diode itself is actually made up of 2 layers of semiconductors, so called because you have something like a p-doped and an n-doped semiconductor, which is positive and negative. Positives are represented by electrons, negatives are electron and positives are holes. But the point is, when you put these two together, you suddenly have a boundary condition where these two connect. And so you have a boundary layer that is formed by the difference in materials. When you have a charge going through this thing of positives and negatives, those will create their own boundary conditions that will eventually collide with this boundary condition. And all of a sudden, all those holes and electrons allow for a cascade of current through your device. So what a diode does is, as you get up in the voltage, it will start to let power through exponentially. So you have a triggering voltage when it'll let everything through. When you reverse voltage a diode, it typically will block. But if you have a Zener diode, it will suddenly super duper drop off. And what that means is that any additional current going into the thing will be shorted. It'll be just basically used in the circuit. It'll be bypassed. So what you have here is, because of this diode here, anything that is above 10 volts goes down this way, and 10 volts is preserved on this junction. So since this is creating a negative 10 volts, that is in backwards. And this is ceramic, so it doesn't matter what direction it's in. Don't be fooled by the Emily Gillette wrong symbol here. That should look like this, which is just 2 flat plates, because it's not polar. That kind of bugs me. So what we'll be doing is reversing this diode so that we can have a positive voltage up here. Let me just write that down. Let me just get that onto the thing. Oops. The temptation is there for me to make this in CAD and create a circuit board. It's an ever-present temptation, and I have to resist. And then 180. Grab it again. Bring it back down into here. Beautiful. So now that's AREF 10. Oops. AREF plus 10. There we go. Yeah, because it's exponential is why we don't use any old diode for this. There's a lot more nuance to what I'm talking about, and if you really want to get into it, I would have to open up Wikipedia to make sure that I'm saying the right stuff. That was the dollar store, the dime store explanation of how that stuff is working. How I think of it and represent it, I don't think of the entire equation. I don't think of the layers of silicon every time I do that stuff. I just hope that I'm close enough. And you can look it up on Wikipedia. It's a basic Wikipedia article. The physics of holes and electrons we don't typically consider. We consider there's a voltage drop across the diode, and it has certain properties. And especially in circuits like this, we're doing a lot of we're thinking about it in much different ways. Yeah, that's why the data sheet. Zener diodes are baked a little bit differently, and they have different properties. They have different negative properties, which is why we're hooking it up backwards. Yeah, and the data sheet internally shows this thing as a diode, but there's more to it. It's actually not just a diode. The LM4040 isn't just a diode. In fact, if we open up the data sheet, the data chart, we get to see that internally, and this is one of the few data sheets that actually gives you an internal circuit diagram, it's actually represented by different transistor and comparator elements. This is just a functional block diagram. The actual stuff is the secret sauce that they don't show you. They don't really show you exactly how it does it, but this is how you would consider it if you were thinking in terms of transistors and stuff, which is pretty crazy. It's pretty complicated for what it is. That's why it's so accurate. Anyway, going back up, I just need this to be up on another screen. And then we build circuit. Okay, so I just need that 470 nanofarad capacitor on this thing. What capacitors do I have? Let's see. I think I've got like a little kit for these ones specifically. Oh God, where did that kit go? It's somewhere in this surface mount mess. this thing that I need to organize a little bit. Oh God, I'm crushing my balls by sitting like this. What are you? Oh, what? Boutons. 470N. What is that in U? I think it's 0.47, isn't it? 100N is 0.1. 470, 0.47. Yeah, okay. Yeah, we got those. 0.47. 474. I'm gonna slip and end up punching my balls on this stool. I'm sitting kind of Riker style right now, so the gentlemen are in the mix. 474, here we go. Wait, how come I haven't used any of these? 0.47, 474. I wonder, I probably have them in one of the other bins. Fairly common value, the 47s. Yeah, you can basically treat it as a slightly better Zener. I've never worked with them before outside of modular stuff, and since Amelia uses it, I assume that it's the best, because Amelia's modules are probably the best. They do all the good circuit practices. You're still working through it. What a baller. I'm not quite a shot caller. And I don't have a girl in the hood. I would call her. All right, so we are just basically creating this, but with the inverted thing, and somehow a larger cap than what's here. It's probably a higher voltage rating. So basically all I need to do is flip that little guy the opposite direction. Or I could flip it upside down, but I'm not going to do that. I'll just do this. And then we're placing it way down here. Way down here. And then we're putting a capacitor across it. Not what I signed up for. Okay, there we go. Like so. So I'll just put one leg of each of these down, and then I can get the wire in here. Let's get the resistor up top. Just like that. Of course, my hand is blocking the light. I gotta raise the light up a little bit so we can see the soldering. Actually, I need to twist the light too, so my counterweight. I have a giant C-clamp on this thing that's a counterweight. C is for counterweight. There we go. A little bit more light in our area. I have to deal with a lot of shadows because I can only put light sources in certain places. It would have been a good setup if I didn't use a restricted top shelf and I had all of my lights there. If these are a little bit further out towards where I'm working, or I could alternatively put like a ring light on the microscope, which I've experimented with, but I just haven't found anything that I really like. I just struggle with this giant barn door setup next to me. And it works for most part, for the most part. It worked for most part. This setup I did not just buy and deploy. I've been streaming with it for quite some time in order to settle on some of the different elements of it that I like. So it's very highly personal, this setup. It's very personnel, kid. Teleports behind you. Yeah, I got kind of a quiet weekend, so I decided to stream today to make up for Friday. Friday, life kind of got in the way. We have a family member, I guess I could say. This is an NC, right? That's not connected to anything. They just put a little dot next to it on the data sheet. I'm going to push it up against this, but I should give it a little bit of breathing room. We have a practically family member, a family friend who's in kind of dire straits. She's on her last, and so there may be interruptions to streams in the future, and I'll be vague about my subject and, you know, why I'm delaying, but it's because she's kind of getting to the end. These are people that I've known since I was a baby. That's all right. No, don't worry about it. She's been in a vegetative state for quite some time. So this is kind of like a, well, finally thing. Any thoughts of grievances that I've had before, I've worked through already. There's nothing new. But hey, do yourselves a favor and put a DNR on your driver's license. There's a reason that all the doctors have DNRs on their shit. Been there too. It's really tough times. Yeah, it's just, you know, what do? You can't do anything. It's out of your control. So you just wait. All right, let's get some resistor in here. 3301, the thing I love, I absolutely adore about surface mount resistors is they have their values written on them. And the value is written in no code unless you have those really obnoxious surface mount resistors that have like a D. If there's like a letter in there, you have to look up what the value is online unless you're a freak and you've memorized that. But you don't have to be a freak. You don't have to memorize these because typically you have 2 or 3 digits and then a number which represents the number of zeros at the end. So 3301 is 330 with 1 0 at the end. So that's 3.3K. Easy peasy. It's so easy. All right, let's get the rest of this thing soldered, and then I need to make a little label for it. I need like a scrap of wire wrap, which I don't think I have. I have resistor scraps sitting all over the place, though. We'll just use those. I made a meatball hoagie out of supermarket meatballs for lunch, and it was perfect. And the one thing that I believe has always been missing in my meatball hoagies and in general, in my sandwich making in general, is I neglect buttering the bread. There's something very special about buttering the bread before making a sandwich. And this time I buttered the bread, and it was perfect. Utterly without flaw. It was insane. I think I just leveled up in a sense. All right, get that one there. I want to make sure that these things are anchored as I'm soldering them because otherwise they kind of fly around on the board. So I'm going to get the other side here soldered in, and then I'll be able to come back to this and make sure that that whole thing is soldered. Okay, that's not quite working out. Maybe I can get to the other side here. That'll go a little bit flatter. There we go. And now I'm just going to bend it so that it makes contact with that other row of holes. Ooh, careful. Don't mess up the device. Just give it that much. That's all it needs. Oh yeah, I can solder this whole thing. So I'll solder this while I'm here. This needs to be moved in. My light needs to be moved in or else my shadows are way too hard. They go too hard. Go. What they want you to do is apply the heat to the pad and then solder to the pad, but sometimes that just doesn't happen. It should be soldered in pretty well, although it probably could use a glob. The problem with these holes are plated through. They're not only on one side. I appreciate working with one-sided PCB, breadboard, perf board, one-sided perf board when I'm doing surface mount, because then the solder doesn't fall down into the other layer and you have a completely insulated bottom layer to run all your wires. But I've run out of that stuff and I need to find where I can order more of it. Another strategy for getting around this is to put a piece of Kapton tape under the PCB. That way you don't get it bulging out on the other side. But alas, we do not need to do that right now. This is a cheap, quick, and easy shunt setup. All things considered, I could probably use those little custom PCBs, the little already etched ones to make this, but I haven't quite figured out that one yet. There's ones that have little pads on the other side. They're kind of special, but you can use them, and then they have little label areas where you could write down what the part is. I hope this one doesn't get hot. The other one gets like burned to the touch hot. I don't know how to prevent that. Maybe a smaller resistor going in if it got the 1K instead of the 3K. Well, that went in sloppy. See if we can just get the whole thing to even out. There we go. That's a little better. Okay, now I can clip that. And this is our positive voltage shunt regulator, aka our voltage source. Let's just clean a little bit up here. Oh man. What do you think? Is it puppy feeding time? Oh, we're getting up there in hours. We started early too. We'll hook this up and see how it performs with everybody else. Once I get out my label maker. Gotta make sure to label these things because you're gonna come back to these elements in like 4 years. You're gonna be like, what the hell did I build? And if it's well labeled, you're like, oh, it's a positive shunt regulator. All right, cool. I got a voltage source. With all the modular stuff that we're doing, this may come in handy at some point. Again. All right, that's clean enough. So now that that's clean enough, I need to get my scissors. And we need to make sure that this gets a label. Where's the label? Oh yeah, I put it in the drawers. I got a chest of drawers and I filled it up immediately and it did absolutely fucking nothing to clean up the shop. You were supposed to clean things up around here. It makes it so that I can put my stuff in a dust-free environment. He says while wiping dust off. Tell me you're still doing... Yes, perfect. Do I have a plus symbol on this? I have to go into symbols, don't I? This thing is kind of old. The newer ones have more stuff on it, and I can actually plug it into USB. I fixed things. I have you linked in my title so they can come directly to the source. Hey, that's all right, man. Thank you. Library, symbols. Real, I'm just joking around. So, hazard warnings, electrical, pro AV security, numbers. There it is. Plus. Oops, I deleted the wrong thing. I may have misjudged you. Plus 10. And then turn all of these minuses into pluses using the symbols, using the library. I gotta go through the whole list every single time, don't I? They really make these hard to get to. Why would it be so hard to get to? Library, symbols, numbers, plus. Jeez, that was tough. LM4040 plus 10, ground plus 10 plus 12. Yeah, that's how it goes. Print. Now I gotta cut this to size and get it to fit on the top of that little thing. Haha, don't mind if I do, Dantless big fan. Fucker. I hate those things. There's no way they're profitable. I could sit here and buy viewers. I could buy 1,000 viewers. Nobody would bat an eye. But then could I sleep at night? Yes. The thousands of dollars I'd make from looking like I'm a bigger channel than I am. But then chat wouldn't move. People would know something's up. Nah, I wouldn't be able to sleep at night if I bought viewers. That was so scummy. Hell no. Of course, I cut that really badly. That should also be a capital L, but whatever. A capital L is buying viewers. What sadist designed these label keyboards? Yeah, really. I like the newer ones are a lot better, but they're not a small purchase either. So I'm stuck with my old one. But then in addition to everything else, because it's a thermal printer, it takes like 60 batteries in order to run the damn thing. Like I got to find 11 AA's when that thing runs out of power. And it seems to immediately drain the batteries and then coast off of low battery for an inordinate amount of time until it just dies on you and you need another $25 worth of batteries just to run it. I think the newer ones are rechargeable because everything's rechargeable. All right, so fit what I can, and everything else gets chopped. It's criminal. Yeah, it's like in this case, enough of it's labeled where I can figure out what's going on. And since these are the thermally printed labels, they last a while. You know, you can't smudge them or anything, and they don't fade out after a huge amount of time. That thing takes 5 batteries. Look at this here. Let me get it out again. Four, and then 5, 6 below. Yeah. 6 batteries, 2 banks of 3. Solar panels? My neighbor just fills his garage and I'm jealous. I mean, I love solar panels. I think everybody should have them. I wish I could have them here. The HOA sucks. They don't think we should have solar panels, even though they could fill a field with panels. I think every house in this neighborhood should have solar panels, and we should have a building dedicated to battery backup so that we have a fully functional, quiet power outage solution for the whole neighborhood. Because they could just put a big shed out there. They could just put a big shed full of batteries. Is an HOA allowed to ban solar panels? I don't know. Probably. But no, that'd be too expensive and blah, 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 blah. None of the neighbors would agree, and everybody just wants to fight each other. It's a sad, sorry situation. Yeah, it looks like this other one's a bit wider, but basically what we're doing is we're just flipping the one component on these and making both of our reference voltages. So what I am now able to do is plug our new hardware in and our old hardware in. Now, where am I going to find space for this thing? The plus 10 shunt. Currently, this one is hooked up to the negative voltage rail. So this would be the negative V. And we get ground plus 10, or plus 12, ground minus 12 and minus 10. And I guess I could do the other one over here if we move this wire over a little bit. So I need a couple little jumpers. Let us grab plus 12, which is over there. Yeah, plus 12. I've really got to cram things into this board because we're running out of space for everything. It's good to space out your project, though. Don't get me wrong on that one. Space everything out. You want room to work. You want room to think. You want room to breathe. Looks like I need jumpers that I've been using a lot. Hold on a second. So this one will be ground. So this one, if I plug it in, I could do it either way. I guess I'll plug it in so that I can see the labels. So plus 12 is over there. plus 10 is there. We'll do a ground right here like this. It's going to really kind of squeeze things in, isn't it? Ah! Yeah, there's some people in my Discord that are actually building their own battery walls. It's a pretty crazy project. I think one of them had a fire. I'm not sure. I don't think they're around as much anymore. I don't know if it's due to the fire or if they've just kind of moved on. People come and go, you know, they move on to different content. That's just how people work. Where was my good thing of... I had a thing that had all the different sizes of jumpers in it. See, I'm running out. These bins, like, I use the little yellow jumpers quite a lot, and so those go away faster than any of the others. Oh, it's too long. I have my old one that took all of the excess from all the others. This one will have the right size. I'm scared of battery walls. It's a lot of energy. Yeah, it really is a lot of energy. I mean, the battery management systems have gotten really good, so I don't think there's a ton to worry about. But if there's some other fire and it gets to your battery wall, you know, what do you do? Guess I'll die. Is this the right? That one looks too long. Yeah, it's too long. Slightly smaller. This one doesn't look like the right distance, but it might be. No, it needs to be slightly longer than that. This is basically just the garbage bin, where theoretically I can find the size that I'm looking for, but anybody's guess at this point. Oh my god, I need to bring this further to my face to see what I'm doing. Streaming has you do things in all kinds of different positions. All sorts of contortion is going on here. Is this the right length? It looks too long. It looks like one of the other sizes. It's way too long. I need a kit of wire jumpers that has weighted averages in terms of usage. So the sizes where you're jumping the power bus into the circuit, those should be the ones that are emphasized. Just mix and match 5 different kits and put together one that has all the right sizes. Oh my god, this thing is too long. My eyes are uncalibrated for this distance. A lot of the emphasis of when I do breadboard circuits is on cleanliness. The cleaner your circuit goes down, the easier it is to troubleshoot in the end. So you want to make sure that all the stuff is going in nice and clean. And you have a minimal amount of jumping over fellow wires. Now that's starting to all go to the go to hell right now in this circuit, because this circuit is getting big. This is a stress test circuit, so a lot of different elements are coming together in order to make this, and we use solderless breadboard because we're not committing to anything, and then we can on the fly change elements of the circuit in order to cater for different functionalities that we might want. All right, so there's our shunt. We're gonna, I guess, power up this board and just test the voltage on the shunt. You could use that expensive paste lead bending tool to make some wires. Yes, and I've done that before. I've cut them and made my own jumpers, but hey, you know, if I can find a jumper somewhere, I'd rather do that. Plus, all the different colors make it easier for me to find where wires are going. Get the scissors out of here. And then we'll turn back on the output. Yeah, some people just keep the solid core wire and they just cut their own. I've heard a lot of people that just say that, just cut my own. Oh, I'm getting my leads off the floor here. So voltage, this over here. We don't need these. Oh, and I need to make sure that my alligator clips are still clipped. You know, the O-scope is probably more accurate than the multimeter at this point. These are still good? Okay. So I don't need to power anything else up yet. I can just test the shunt. So we're going from ground to what's going to be our positive 10. And I'll turn on 12 volts. Yeah. And we get 999. So 999. Let's see how hot it gets. There's nothing on the output, and everything else it's going to see is high Z. The 5-volt regulator got hot like immediately. Looking at this right here. Now, how come this one gets hot? Look at that. Look at how hot that's getting. It's only sending 10 volts out to one element of the circuit, and it's got the same stuff on both of these. Is the capacitor what's getting hot? Oh, I think the capacitor might not be rated for the voltages. No, I see 3 leads on that. That's definitely the 3-leaded device. I don't think the capacitor's overheating. I need to get a sip of seltzer water because my throat is getting real dry. My throat. I know Rabaz today. For sure. Rabaz has been doing a lot of game development, and he's been doing actually a wonderful job building an environment in Blender out of squares using that minimalist horror game style. It's been amazing to watch. Is it under load? What is negative? Negative 10 is going into the op amp and the Max 308. In terms of whether or not it's under load, I don't think there's very much going on there. Let's get the 5-volt regulator separated from the Max, and then I can send 10 volts over to that, and maybe that'll heat it up. Maybe that'll heat it up. Where's my tweeter? I didn't take a sip of the seltzer. I just got the seltzer. Hold on a sec. I'm going to hydrate. Okay, I've taken a sip. Let's get the multimeter out of the way. I may have to bust out onto other breadboards in order to make more of this circuit. This might get that crazy. Might get that rowdy. So let's take 5 volts off of the Max. Wait, what pin is that? The Max gets 5 volts, but only to enable it. Oh, but it's jumping from there to there, so I might have to alter that part of the circuit. Oops. All right, say goodbye to 5 volts. So this is enable, so that goes here. So here we need to send our 10 volts. And I guess I'll just use a big wire to get over there. So that's going here. Oh, could actually be a little shorter than that. Good. Can I get there with a green? The intrepid green wire. I should probably power down while I'm doing this. I'm going to power down just so I don't blow anything up. It's the times when you're arrogant and you don't power down that things go severely wrong. And you end up crying. There we go. All right, that's pretty tidy. So we're still enabling the Max 308 with 5 volts, which is, I need to plug it back in. What direction do you go in? V in, V out, ground. It's like this. V in coming from 12, out, ground. Yeah, that's correct. And then out also goes over there. Okay, cool. That's all back in. The thermal camera is nice. I just use my fingers. That's what I used to do, and my moderator got not mad at me, but he got very perturbed that I kept burning myself on circuit elements, because I will routinely just poke stuff, and I still do it. But we ended up setting up with a Lepton 3.5 and a Group Gets thermal camera module, and then I had to print a 3D enclosure. I had to actually print a 3D printed enclosure. Oops, I moved that scene to where it's not supposed to go, because the Group Gets thermal camera uses a Molex socket for the thermal imager, which drops the thermal imager if you bump it slightly. And since it's on my active moving desk cam rig, it needed something around it, but it also needed a lot of vents, because if the thermal camera overheats, everything ends up looking like the same temperature. And for some reason, it creates a lot of heat in its running. So we made the enclosure with all of the vents on it, and that gives us a nice stable platform. I do wish I had a switch on it so that I could turn it off when I'm not using it, because it runs 24/7, but there's a physical plastic piece that goes over the lens in order to calibrate it, and that physical thing is what wears away. That's what broke when it dropped out. It's been amazing and totally solid for quite a bit of time, though, with the enclosure. All right, so now we have selectable, delectable. We have selectable plus and minus 10 volts. The next step is going to be doing some coding and doing a little bit of digital hookups, a little bit of maybe we just go right into I2C, and that'll hook up to the port expander, so that the diagrams are going to expand exponentially. Everything's going to go crazy. Since I've been streaming for about 3 hours, which is usually where I limit myself, at least these days, because I need to be more present upstairs. We'll do longer streams in the future. It's just right now some things are happening. Selectable, delectable, delightful, delicious. We'll forward that over to the marketing team. We have, so far, because of the bigger raid earlier in the stream, I had to do a lot of explaining today. I was going to try to hit the ground running, but there's a lot of explanation into like what we're doing, and it's complicated. So what we've been able to do over what we previously had accomplished is we now have we have the feedback for DC voltage levels on the AC lines is going directly into the Arduino. It's going directly into the TNC4, which we know can handle, with the tuning that we've given it, it can handle the maximum voltage level that is going to be present on that line, which is going to be 3.8 volts. But it cannot sense 3.8 volts. It doesn't sense all the way to its maximum. So we tamped down that value a little bit. And since the op-amp can't provide more voltage than that anyway, our system is safe. So far, the digital part of our system here is safe. Now we know that those values are also the maximums that this thing can sense. It's a little bit narrowed from what it can sense maximally, but the Arduino is now able to check in on that DC voltage level. So what we're able to do is send a positive and negative 10 volts into what is being interpreted as input. So the input here, we can sense positive 10, negative 10. We can tell this is positive 10, this is negative 10. We can make a waveform over here that is at maximum amplitude, positive and negative 10 volts, and sense it back with this and calibrate what those values are all set to. So the system of our Arduino sensing of a DC voltage and having very accurate voltage shunts go directly to the input means that we can calibrate our input and we can calibrate our output. Yeah, it is. It's basically, I've set up the channels as being universal IOs, but because we only have 2 channels, we've had to split those 2 channels and make them selectable. But because we're using an 8-port MUX, we have 2 extra ports. So why not take 2 very accurate shunt voltage level setters and put them into those 2 channels so that we can calibrate each element of our in and out. And so what we'll be able to do is during startup, much like my oscilloscope does, it takes forever to start up, we can have an algorithm in place that'll do some reading and averaging that'll get this thing to be as accurate as we can possibly get it. It's pretty cool stuff. We need a sequence of events of what we can read. And so we'll start here and we'll read plus minus 10 volts, and then we'll output what we can read back as plus minus. So we can do a DC voltage level out of these, and then that'll scale the value that we send to these, and then we can read these with this. Whew. All right. Well, that was kind of not a long Saturday stream. It was the shortest Saturday stream. Among the people who are live. I don't know if there's anybody I want to filter you guys to. If Gonad was around, I'd do that. Let me just open Twitch real quick. I had like supermarket meatballs on bread with butter, so all that fat is just making me hiccup constantly, and I'm miserable. Davies is doing My Summer Car, if you want to check that out. Other than that, nobody on my lists are active. It is a quiet Saturday. I would keep streaming, but I do need to be present upstairs just in case people need my help with stuff. So I am ending early. I will be on Discord. You guys can check me out here. Yeah, it is. It's a slow Saturday, which is usually a good thing for me, because then if I stream, I get a lot of viewers. But I will be on Discord, and I'm going to continue to work on this stuff. I'm going to set up a test where I can switch the channels, and maybe I'll have to incorporate the knob. And so maybe I can get the knob running on I2C. Who knows? But if I can incorporate the knob, then we can switch between our inputs arbitrarily, and I can view the different inputs, and then we can see our plus minus 10 and all that good stuff, right? So we're getting there. We're getting there. The complexity is ramping up. We are going to get this thing done. The UI and the screen stuff are what really scares me. So I don't know when I'm going to be able to get around to that. But I want this piece of test equipment to work so that I can move on to other stuff. But that was really cool. The analog read in the loop, with the loop doing nothing else but looping, so it's at a super duper high speed. With the analog read charting, we got a sawtooth wave in the analog read values. That was cool. All right, until then, I will catch you on Tuesday, which is in approximately 2 days, 21 hours, and 16 minutes and 15 seconds. Just spent the last hour figuring out how a sax is laid out. Yeah, when you get into that, it's like a synthesizer in its own right, huh? All right, well...